Hey, good morning, guys. So today I'm going to do a little workshop how to build a relatively simple DappNode package. I hope that you know what DappNode is, so that's why you're here. But I'm wondering whether you have done anything on DappNode, any of you. All right? And that's not that important. The important thing is, for you to be able to follow workshop, you need to be familiar with Docker a little bit. Okay. So I'll show the flow. So my idea is to make a package like live in front of you, and that is not like crypto package because DappNode is more than just like a staking machine. It can do much more. It's your own server, so you can do whatever. And I had the idea of doing the um, OSIS package. OSIS means on cloud infinite scale. That's the newest product, newest release of on cloud open source service. So I can show you. So my idea is to build this as a DappNode package. So that's your own cloud storage that you host. You don't share you don't share your data with anybody, and it's completely private. So DappNode can do that and can do that easily, and I'm going to demonstrate you. So I'm going to show you like real process how I do it, and it's a bit of iterative process because at the front I don't know what's going on, what are the package requirements, and it's a bit of a trial and error situation. So first, for us to be able to do a package easily, we would like that the package has its like official Docker image, and that simplifies process massively. So if the easiest way to find that is to go to the docs of a package and go to, for example, deployment, and try to find some kind of basic setup or getting started or something that shows you how to run this first with Docker, and then like within the DappNode. Okay, I found this in docs, which redirects us to this, which redirects us back to the same page. Okay, I think it's in basic remote setup. So Docker compose, development examples, basic. I found this a day ago. So we need Docker. Let's do it like this. So discover OSIS with Docker. Yeah, this is it. So these are the OSIS docs. We are still not doing any DappNode related stuff that tell us how to deploy OSIS with Docker. And if we scroll down a bit, it tells us to prepare directories. That's fine. To do the and to change ownership of directories. That's fine. We don't care about that. We care about this Docker pull. Okay, we need to pull the image, and we need to run this Docker command, which initializes the OSIS, and then we have to run this bigger command that runs OSIS indefinitely. So that's like a bit of anti-pattern in DappNode, because in DappNode we just want it like to start, run it, and that's it. But we can solve that. So let's now that we have the idea how it works, we can go to our own machine, and we can choose the folder where we are going to build stuff. So on my PC, I do it in code the DappNode folder. It doesn't matter. And let's create the folder where we are going to build our project in. So as a standard, we name them like this: DappNode package. dash whatever name of the project is. Let's call it OSIS. So we change to that folder, and now we start coding. So we have a tool called DappNode SDK that's meant to facilitate this process. And first thing that we need to do in this folder is initialize DappNode repo. So we use DappNode SDK command, but we won't publish anything still. And we will do init command. And this will guide us now through the defaults. We will use the package that's default from the folder name. We will use version. We will type in description later. I'll tell you where these fields are. For author, we'll put a DappNode. License GPL 3.0 doesn't matter right now. And that's it. We are now initialized. And we can open our IDE. Thank you for. And now we have basic structure of our DappNode repo. We start for the Docker file because that's that's the first thing we see. And what we do with the DappNode package is we just take the whatever we are doing, whatever package we are doing. In this case, OSIS. We take that image as a base image to our own image that we are building with the DappNode. So you see here we know that name of the image is onCloud.osis, and what we do is we say from onCloud.osis that means that our entry point is the onCloud.osis official image, but we won't have version tracking of this, because when you do this will pull the latest image, and then you won't know what you're doing. And then what we standardly do is we tag them, and we always use upstream version variable, but we need to define that first, and we will define that in Docker Compose. I'll tell you later why. But here we just need to declare it, and we declare it as argument upstream version from OSIS Cloud, and that's it. For now, what we need to add here is that that upstream version variable. Also here, it won't be OSIS version, it will be upstream version. And we want it to be the latest one there is, so we'll just Google it. Okay, not like that. So we'll just Google it, and we'll see what's the latest versions, because we want to build on top of the latest version. There is no sense in building anything else. And that's 7.1.3, and we defined it at 7.1.3. And this is our basic setup. So what we can do now is we can try building this. Obviously, it won't work because we saw here that we first need to run this init command, but it doesn't matter. We can just try building it. And now my connection to the DappNode is broken because I haven't connected to the VPN. So what build command does is uses your Docker to build the package and then to upload it to IPFS. If you don't have IPFS endpoint, you can't do it. But luckily, so I have DappNode here in my WireGuard, and I can connect to it. Can we give people IPFS input? So if you are following with me, if you are trying to do No, it's fine. So if you are following me and you want to do this with me, there is way to do this without having to connect your Dapp node. So what you then have to do is you have to add additional argument variable, which is called provider, which is IPFS provider, and then you write either like HTTP of IPFS API, or you use like our own that we use for developing, but we often purge it, so you cannot count on it. So we call it remote. And if you do this, this will work even without connecting to your Dapp node. But as I'm connected to my Dapp node, then I don't need a remote provider. I can just use Dapp node SDK build. And now it's a building an image. And it takes a while. And while it's obviously already built it, because our Docker file is very simple. So it's just now saving and compressing, and later it will upload it to IPFS. So this obviously won't work because we didn't, but I'll show you the process till the end, at least now, and then later we will iterate more quickly. So while this is happening, does anybody have any questions? Is anything clear? Everything clear? All right. So we can wait a while. So this is being built, and while it's going on, we can see here in more detail what we need to do. So first we need to init this thing, and then we will get some kind of user and password. I don't know right now what that is, but we will figure it out. All right. So it has been built very quickly, and it has been uploaded to my IPFS. So from here I can try to install it on my Dapp node. So I've got a link here, and I can follow it. So this is opened on my Dapp node, and now it will try to load it. At some point, but let's do this. This is irrelevant to the. This will make it load more quickly, I hope. Yes. So I have the basic package now built. It doesn't look very pretty. It doesn't have avatar. It says that release is not signed, that it's unsafe, and if you try to update it, you won't be able to, because you have to check the advanced options to bypass restrictions that we have.
These restrictions are because when users are mostly using Dapp node in order to stake and to validate, yes, and they have validators and everything, and since the SDK is permissionless and anybody can create Dapp node packages, anybody could just create a package that's called Prism consensus validator, yes, for example, and people would just download it thinking that it is. But if it's not signed by the original poster of the Prism package, then it will not be accepted. So packages include a signature with the developer key, and the Dapp node can recognize when somebody is trying to impersonate another package that's not been signed by the developer address that's allowed to sign this.
Yes, exactly. So Dapp node philosophy is you can do whatever you want. You can install whatever package do you want, but we want you to know what you are doing. So it's not signed. That means it has been released by whomever, but you can install it, and you do it on your own risk. But we have like very robust system that tells you from us that the package is signed, and then you can, I mean, trust the author, either us or developer of that package, whoever that is. So I'm going to try to install it now. I will click on update because I already have like this package that's called OSIS, and it will try to install it. And first that we do when we install a package is we look at the logs and see what's wrong, because on first try it's almost certainly going to be something wrong with it. I mean, we are on purpose doing something wrong right now, but yeah, I want to show the process, because I've never built a package in the first try. So yeah, I want to show you how it is. So if you go to the logs, so yeah, it's like giving me some weird error and nothing works. Because when we go back to the docs, we have to do first time initialization, and here we see that we need to provide it with 2 volumes. So we will do that right away. First, volumes are both same in this Docker run and this Docker run command, so we can safely mount them. So what we can do is we can write volume command, and my copilot is telling me what to do. I think almost correctly, because I don't want these to be bind mounts. I want these to be real Docker volumes. So what we do, this is basic Docker stuff. This has nothing to do with that node. We just specify these volumes and declare volumes here as is per Docker spec. What DappNode SDK for some reason wants is that you add these empty brackets to it, so your validation passes. All right, so this is this part, like this mounting part. And next part, what we need to do is this own cloud init step. And since we need to do these both steps inside of the Docker volume, the DappNode package, and without interaction with the user, so what we do is usually we write a simple bash script that help us deal with that, and usually we call it entrypoint.sh. So I will create that. I will make it executable. And now we can route our entry point script. So, but because we wrote our entry point script, we would need to change our Docker file. So it's not as simple as it was a few moments ago. And then we will change it. First, we will set work directory to the standard one. In DappNode, it's user source app. This is irrelevant from the DappNode perspective. We would need to change, we would need to copy our entry point to the destination. And we have to specify now with the Docker command entry point that our entry point is the entry point. Yeah. And this is our Docker file that we are going to use. So thanks. So that's pretty much it for our Docker file, and all the complex logic happens here. So let's save our Docker file. We saved our Docker compose, and in the entry point, we try to do what's been done here. So these are 2 steps. So one is that we need to init, and second step is that we need to run it like this. So first step is, as I said, osys init. What's the name? And it says we need to do it with insecure-yes. So what this means for I don't know for right now, but what we can do is what we can SSH, for example, into some Linux machine, and then we can try Docker run okay. For example, help. It can't find the image, but it will download it. And then this is help command. So maybe we can do OSIS init help. And this tells us usage of the init command. So it says options that we have and their default values. So allow insecure OSIS config. That doesn't sound benign, but it's okay because everything is tucked in Docker, so we don't need to worry about it. But it says admin password and set admin password and using random generated one. So it says here that when you are doing the OSIS init command, that your password is randomly generated if you don't send admin password value. And that's something that we do not like, because that would users wouldn't be able to set their password, and their password would be, they would like have to fish it out of the logs. So and that's not very optimal. So what we can do is using this OSIS init command, we can set admin password to some value, and let's call that value OSIS admin password. So that's some kind of variable that user will be able to set. So in that node, we interact with the packages using environment variables mostly. So what we do is we need to set this environment variable, and we do that in Docker Compose. So Docker Compose is a file that DappNode reads and builds your interface around the DappNode package around it. So whatever environment variable is defined in the Compose, it is shown on the UI. So environment admin password equals, let's do it like this. We'll set it empty, so that user is forced to set. Yes.
Yeah. Could you please zoom in because
Ah, okay. So I will zoom in. So the question was, can I zoom in? Yeah, definitely. Is it better?
Yeah.
Yeah, I can do it even more if you want. So yeah, right now we have our entry point set, environment set that we need to insert admin password, and we are doing our OSIS init. Nice. Next, after we've done OSIS init, we need to do this command, and this command is a bit tricky because it is using default entry point, and we don't know what that is. But we can easily find out in, for example, for the OSIS, it's easiest to do it in the GitHub, Docker Hub. And you can see here that default entry point is OSIS. I'll zoom it. And the command is server. That means what we can do is we can do just OSIS server, and that should be good enough, except the rest of the environment variables. So for running OSIS, we need to expose the port. It says 9200. We'll set the default. We don't have reason to change it. So we can expose the port. Actually, we don't, let me backtrack on that. We don't, in DappNode, so how DappNode works is that you are connected to your own network. So when you connect to DappNode, you connect to the internal Docker network of a DappNode. So you don't have to expose the ports. But to be able to access every possible port of of the container. So we'll skip this one, but we would need to copy these environment variables. So we'll need to figure out what these are. But let them copy for now. So OSIS insecure equals true. We've already said that. Proxy, HTTP proxy address. This, to keep this more dynamic, the HTTPS proxy address is the address on which internal process is going to listen in OSIS. So because the default port is 9200, we'll set it to 9200, and 000 means that OSIS will listen to all interfaces that are available to them. And that is a requirement where we are doing anything Docker related. And this last one, OSIS URL, is an interesting one because it makes us set URL that we will be accessing OSIS from in advance. And so when you install a Docker package, it automatically gives you domain names for your package. And I can tell you if you do public package, which this is. So if you go over here, it says OSIS public package, and this is actually domain that you are able to connect to your package, whatever you do it. So what we can do here is we can just copy paste that there, and we should be set. All right, so we can double check. We changed the environment, we did the volumes, and that's pretty much it. We did init. And yeah, what we can do next is we can try to build the package again and see if it works. Build. Oh. Again, it has been built very quickly because this Docker file is extremely simple, but it doesn't matter that it doesn't mean that everything is going to go smooth. So what's the next step of process is we iterate, as I said. So we built a package, we think it could be good, we install it and see what's going on. So as before, while we wait for this, is there any question? All right. It should be done very quickly, as it is pretty lightweight package, I think. We have it here. And you see, in the package UI, it picked up the version of our package and the upstream version because DappNode understands upstream version argument in the compose. So we have it here. We can have it installed. It's again not signed. We can bypass save disclaimer, but what I'm going to show you is usually when I'm building a package, I usually click this show advanced editor, and that advanced editor shows us what we've set in the compose over here, right? We have 4 environment variables. We have these set and his volumes, and we do not want custom mount path. We want a default, and what we need to do is set the password. We can set it as DappCon. And then now it's in the plain text, but we can change that later. So accept, save, and it's being installed. So because I'm using my own DappNode when I'm building the package, and package gets uploaded to IPFS node of my DappNode, it gets downloaded very quickly because it's on the same machine. So yes, so we have it installed. Let's see logs. All right. It says that it generated OSIS config. That seems fine. Let's try to go to the OSIS URL we specified here and see if it's going to work. Okay. So this connection is not private. That happens because we are using HTTPS here, and then we have to go around this. So this is limitation I found. Yeah, and then we have our own package. We can go admin, DappCon, and we're in. So we'll build like version 0 of our package. So this is only, right now this is only accessible for around DappNode. It has this DappNode private domain, and you can use it. It has this ugly warning that your connection is not secure. And as I said, that's OSIS thing, because it forces us to have HTTPS connection wherever. So in DappNode, so when you are accessing your DappNode, we build it that you are either on VPN, you are on a private Wi-Fi, or you are using Tailscale, which is also kind of VPN. So necessarily, it's not required to have a HTTPS connection for you to be safe. So because you are in a sandbox secure environment, and usually when we build packages, we do not use HTTPS. For example, I have Rotkey here, and when I click on the UI here, you see Rotkey here is not using HTTPS. It's not shown, but it's not using HTTPS. But if we try to do the same thing with OSIS, for example, if we change URL, we want it to be HTTP and update it. This will now change the environment variable and restart the package. Yes?
Sorry,
can you have my microphone, please?
Sorry, one thing I didn't follow, I may have missed it early on. This .dappnode address, so you're on your laptop there, and you're talking to your DappNode?
Yes.
How is that resolving? Like, how is that actually?
Yeah, because we are using, I'm using VPN here, which is connected to my DappNode, and when you are using VPN, you can set up on your DNS server. And that DNS server is also a DappNode package. You can see it here. And it's made to resolve, in this case, Docker aliases. And every package install has Docker aliases that ends with a DappNode. Your main UI, we call it Dapp Manager, has my.dappnode domain, and that's how are those resolved.
Okay, got it.
Any other question? All right. So now we can see that our package is crashing. It can't start. And in logs. So yeah, could not create config. Config file already exists. All right. So that's a bug with our package. So what we did is we just, in our entry point, we just did OSIS init and OSIS server. But so we have two solutions to this. We can use force overwrite flag, or we can do some if else in here if we want to, if we want this to execute only once. For example, we can check for a file, and if that file exists, we don't do it, and if it doesn't exist, we do OSIS init and initialize the file. But in this case, I think it's better for us to use this force override flag, because in other case, the init file, init will be run only once, and in case we change our admin password, this won't be run again. So I think it's better to do force override here, and then when we change in our config admin file, this init will be changed again. So yeah, let's do it like that, and we can rebuild our package. But because this this config file is baked into our volumes, what we can do is we can now remove the volumes, and that will fix our issue because we deleted our config file. But that's just temporary, so we can see what's going on. Now we have different error. So this is one I was aiming for before. So it says invalid ISS value URL must start with HTTPS. So OSIS is forcing us to do HTTPS, and that's why I did it here first time. So we can update this, delete volumes, and now we should be up and running again. So let's see logs, DappCon admin. I don't see any logs, but yeah, the same warning again. Visit the website, visit. Okay, we are good. So what we can do is we can install the fixed version of our package now that has force override flag set. But I want to show show a couple of more things. So we won't be installing this one. We will installing next iteration. So as you saw, when we did Docker init, it gave us a couple of those default files, and one of those is this Docker package file, which tells DappNode whatever we have in info here. But we have a lot more possibilities here. What we can do is we can specify UI here. So UI here is HTTPS. What was it? This one. So we want users not to guess the guess the URL where stuff happening, and just to have a nice link here. Also, we can do description of a package. This shows up when we are installing. But to see full possibilities here, we can go to the DappNode docs, and we have devs section, and the most useful to me is this file references section, because it says Docker Compose. We have that manifest. We have that as well. So there are a lot of possibilities here. These are pretty straightforward. What you can do, architecture that you want to be built, the requirements, dependencies, types, descriptions, upstream version, whatever. But I want to show you the setup wizard. When we're installing the package, so we typed in the environment variable that's called admin password, bit sketchy. It was in plain text, and that's something that you don't do. That's why we have this setup wizard. That's a that's YAML as well. That builds us our setup wizard, so package installation process is a bit more presentable. So we have example here that I'll copy, and I will create a setup wizard here, and I'll paste it, and we'll change it to our needs. So what we want to do with the setup wizard is have a nice field to set admin password in. So ID is not relevant that much. We will call it admin password, for example. So what's our target? Our target is environment, and environment name, and name of the environment variable is admin password. So we go to setup wizard, we change that to the admin password and service. Service is this. So that refers to the Docker service, Docker Compose service that we are aiming to inject environment variable to. So we change that to service title, OSIS, UI, admin, password. So description of that variable is, I don't know, whatever Copilot said. Yeah. Its secret is true. We do because secret that means that will be masked on the UI. This is pattern that we want it to match. We don't want it to match any pattern. It's not enum. It's just a string. So we just need these fields to be set. We want it to be required. We want to be secret, and we want it to be like this. So let's build the package again. So it has been built very quickly because we just added another file. We didn't change the old ones. So we can install it. So it's still not signed. We can bypass that. We can update it, and now we have this that we just built. It says OSIS UI admin password and the password, and this is what we wrote here, or what AI wrote for us, and that was DappCon. And we can submit that. We can accept that. And remember that we did two things here. We added setup wizard, and we fixed the bug about force overwriting the config. So now when we install, we expect this to be working. And also we added the UI link. All right, we have UI link. Let's see logs. Okay, logs are still a bit sketchy because they show password in plain text. What we can do is, for example, if we don't want to do that, if we want password to be a bit more secure, we can, for example, pipe this output to dev null, and that will hide this output, for example. But since there are no logs, let's see if our UR is working. Yep. Oh, something weird is going on. Let's see what our logs say.
You put dev nil, not dev null.
Yeah, but this is, thank you. But this is just on my local machine. That's not on the package. But yeah, not like that. Yes. So yeah, there is some kind of a login issue. Yeah, let's try to do it like this. Okay, admin. Yep. Ah. DappCon. No, wait. Dapp. Okay, maybe we should have done this. It's admin DappCon. Yep, we are back in. All right, so we had issues with the HTTPS. That's pretty annoying, and also your own cloud backup service is not that useful if you can reach it from anywhere. And we have solution for that. So as a part of DappNode core system, we have something called HTTPS. So that's the package that we maintain, and that's made for easily exposing your internal services to the wild, to the internet. And it's made that you do it with the HTTPS always. And how do you do that? Is you go to your OSIS instance, you go to the network. Oh, it's already done. So, because I've done it before, but let's remove it. And what you can do is you can create a HTTPS domain mapping. So you create a new mapping, and you choose a subdomain. So we want this to be, for example, OSIS. And which port do we want it to connect to? We saw that port is 9200. And these are optional fields that use HTTP basic authentication for you to be even more secure. But since OSIS has its own authentication, we don't need this. So we click Add Mapping. So, yeah, I don't know why we got the error, but OSIS mapping succeeded. And we have an error here. Client sent an HTTP request to an HTTPS server. So we have to fix this, and I'll fix it quickly because we are running out of time. First, what we need to do is change the domain name in the OSIS to match our domain that we are mapping to. That's a limitation of the OSIS itself. So now when we build the setup wizard, we have, for config, we have this nice UI, but we need the advanced editor for this because we didn't specify the rest of the invariant variables. So we update here, and in the compose file, we need to change our default OSIS servers not to be run on HTTPS, but on HTTP. So we need to add here another environment variable that's called SSL insecure. Oh, sorry, SSL insecure equals false. Sorry, SSL in. This is false. And proxy TLS equals false. So, and when we build a package like this, it should work with our external domain. So this disables the TLS or OSIS server, but there is a hard requirement for access to OSIS to be on HTTPS. So what I said before is still true. We need HTTPS, but to access it. But the SSL termination can be either on OSIS server or somewhere upstream. But what it wants is SSL for some reason. So yeah, this is the basic guide how to build a working package. There is a couple more things I wanted to talk about. So for example, when we are using this SDK, we have tooling that help it maintain. For example, there is automatic tool that does bumps on your GitHub actions so that you don't have to follow these upstreams always. It automatically opens you a PR and stuff like that. But this is the basic stuff. What you need to do when you are building the package. Okay, let's install it one last time. Let's click up advanced options. Let's update it. Accept, and here we go. So let's for last minute let's talk. Okay, when we build the package, what do we do? How do we publish it? We use our SDK. We call the publish command. And for some reason, we always have to say what we are bumping to. So we have either bump it to major, minor, or patch version. But when the package new, we don't. That's not important. We can do major, and now this is doing a similar thing, but it will give us a link how to publish our package. Now we have it here installed. I'll delete the volume so we are fresh. So there is no leftovers from before, and we would expect now this to work on our servers, but it doesn't. Yeah, the proxy. For some reason this has not been set properly. For proxy TLS false, this should be true. Update it. see the logs. Updated. Yeah, here we are. And what's good about this is publicly accessible now. I can disconnect from my WireGuard, and it's still working. So you have like your own cloud in the, not cloud, but at home. And yeah, so with the, and yeah, last thing that's left is to show you how the publishing works. Is that you connect to your VPN, you do the release, and then this gives you everything you need to know when you're going to publish. Gives you a link that you can publish it. It gives you prompt to connect your MetaMask to sign the release, and if your signature is trusted, it will show up on the UI sign. So I don't have a wallet in Safari, but that's pretty much it. Excuse me? I can repeat the question. Thank you.
So how else can publishers sign releases?
So I can show you quickly. Let's go here in Chrome. Do I here? So you connect your wallet. We won't use Rappi. We want your origin. So we will use some testnet wallet. We can connect. I don't know why it's asking me for Rappi. I don't want to use Rappi. But yeah, it's just like ordinary signing process. You sign the message, this is my package, this is my wallet, and you sign it, and that signature gets added to IPFS package, and that all gets published on the ARM repo manager that holds the version and IPFS cache, and when you see it in your Dapp node, it shows up as signed.
Do you have a support channel?
Yes.
Where?
In Discord.
Thank you.
Any other question? All right. Thank you very much for being here. I'll be around whole day, so if you have any more questions, I'll be happy to answer them.
Oh, okay, can hear myself. Let's wait for the slides. Yeah? Okay, perfect. Hi, everyone. My name is Zeus. I'm the SAFE ecosystem manager at the SAFE Foundation. And today I wanted to talk to you about building doors rather than cages. And just to set expectations, I'm not going to be talking for a full hour. This is more a talk of like 20, 30 minutes, so don't worry about the time. And what we're going to talk about is basically unlocking portable smart accounts for any Dapp. And what I would like you to imagine right now is a beautiful building with glass walls, you know, this kind of skyscraper experience, which you're really attracted into. You go in, and you're super happy to be inside. But the moment you turn around, you realize that the door locked behind you, and you can't leave anymore. On the other side, we have a building with multiple doors that are wide open for you to enter, and you can have different experiences behind them, and you can leave whenever you want. This is exactly what I would like to encourage you to do, to build the doors that are wide open for the users to enter and allow them an easy way to exit, rather than lock them in within your products. And let's be honest, like, we're all lazy. I've been a developer myself. I know what it means to be a lazy developer. We go for the shortcuts, we go for the easier solution. And I'm sure that all of us have been through the experience of going for a checkout to buy something, and we are going through this long form that again asked us for our address. And what happens is that basically we rage quit, and we don't end up buying the item that we were wanting to buy. So basically, the more complications, the more friction, the more likely that the user will basically leave. The other thing is that the modern customers are jumping between different apps daily. Even like within 1 minute, what we can do is to go to WhatsApp, Twitter, Instagram, go on Telegram, and all on the same phone, all with the same identity, with the same passkeys that allow us to enter them, and there is no friction whatsoever. And what users want is basically the same experience in Web3 as well. And lastly, the account portability is actually keeping your users loyal to your product rather than discouraging them from it. And the concept of making the account just work whenever a user wants to use your app is something that will encourage them to use it more. It's basically compounding network effect, where users do not have any friction because they can see their transaction history, they can see their balances, they can have all their settings that are associated with their account, or they can have also their social graph. And the portability doesn't dilute your brand, it's rather supercharging the adoption and the acquisition. Quick primer on the EOAs, actually plug it into all the different platforms. You can use Gmail, you can use Outlook, you can use the Apple Mail, and whenever I log in, I see all the same emails coming in and coming out. And if I can do it with an email, why shouldn't I be able to do it with my on-chain account as well? So let's talk about the pillars that are key for the account portability. Starting with the keys. Basically, the account portability should enable seamless key rotation so that the ownership stays flexible and secure. What it means for the users is that they can add and rotate the keys whenever they need. They can add new signatories, new owners of the account. They can replace a lost iPhone with a new device, or with a passkey, or for example, with a new hardware wallet. And this all happens without any issue. The account stays the same. And as I mentioned, this can be a rotation process, or they can be added on top of each other. The second key are interfaces, which basically allow us to decouple the accounts from specific apps to be independent and be able to be plugged in into any platform that they're interacting with. And what it means, whether it's a web-based product, whether it's a mobile application, whether it's a client that you interact with in the terminal, whether it's an independent bot that is basically running trades for you 24/7, they are all equal citizens, and they all have the same right to verify signatures from the same account. And moreover, there is no special contract code which is verifying whether this interface is actually the one able to perform operations with the account, so we're not closing the door behind our users. And lastly, data, so that we can preserve the on-chain settings related to the account, so that basically they travel with the account across the apps, and the user doesn't have to redo them every single time on their new profile. They don't have to worry about the imports. All the limitations, flexibilities, new functionalities that they want to add to their account are basically automatically imported in your product. So what it means, we can export modules, guards, and settings. The history, the transaction history is following you. And it also works cross-chain regardless of which network your assets are on. So to recap, the 3 pillars of account portability go as KID. We have the keys, we have interfaces, and we have the data freedom. Pretty easy to remember. So now, Safe. The Safe smart accounts are giving you portability out of the box, thanks to which you can really accelerate the ecosystem innovation. Because obviously, without having this unique experience in tying the user to your product, you have to be more competitive to actually win their attention and make sure that they do want to use you. But with more competition, the market grows faster and there is more innovation coming in. When it comes to the Safe smart accounts, the most important things, Safe contracts are open source. Anyone can have a look at them, they've been audited. Anyone can deploy smart accounts on any chain at any time. And actually, the coverage of smart accounts is very broad. Moreover, right now, I don't know if you've seen Luca's talk on SafeCon. Basically, we already have now pre-deployments for several different stacks, which means that whenever there is a new L2, for example, coming to Optimism, the Safe accounts will already have their addresses pre-deployed so that the users will be able to operate multi-chain. Second of all, the Safe smart account framework is modular. Modular is also the word we've heard quite a lot during this week, I suppose. But it's been with us since the beginning. What the magic is here behind the smart accounts is that the Safe contracts are very simple. But what we can do, what the apps can do, what the users can do, is basically build like this Lego structure out of the modules, which add different functionalities, add more flexibility to the accounts. The guards, which basically do pre and post transaction checks and can add limitations when it comes to the execution of the transactions. And also we have the owners array, which allows you to easily add, remove, check for owners that are linked to the specific account. And lastly, the contracts are battle tested. They've been adopted by many different products, and the accounts are used by individuals, medium-sized organizations to really big players that hold their assets within the Safe smart accounts. And if we have a look at an example, one Safe account can actually travel through a variety of different apps. One use case would be gaming, where the user is simply playing, they get some assets, maybe lose some assets. After losing the assets, they rage quit the game. But then they log into a different dashboard, can be a DeFi product, and within that DeFi product, which is completely unrelated to the game, they can actually see their NFTs they collected or just lost on their dashboard. So they do not need to have a specific account for gaming, specific account for their DeFi dashboard. It all belongs to them, to the same account. The same user, the same account, may be into trading, where they delegate the trading to an AI bot, which is working behind the scenes 24/7. And it will either automatically approve the trades, or, for example, user can log in through a dedicated UI or a different UI, where they have the right, for example, to veto the transactions in a specific amount of time. Lastly, more of an organizational, social case. The user is part of a DAO, and with the same account again that holds a specific DAO tokens, they can vote through Snapshot to take part in the governance. So we do not have any specific account creation, any specific sign-in logics. Is the one identity and the one account that the user owns, and it follows him throughout the diversity of different products. And within the ecosystem, we already have a lot of different projects like WorldCoin, Snapshot, Fileverse, which actually provides the agenda for you guys during the entire DappCon. Payment providers like BaseApp, CowSwap, Brahma, FluidKey, for example, who's also based on safe accounts, and many, many, many more. And these products already can dip into the power of the account portability. So in terms of more practical matters, let's have a look at how SAFE enables these three key pillars that I've been talking about before. So first of all, the key freedom is enabled thanks to the owner array, as well as the EAP 1271 signature standard, which basically allows you to have instant non-custodial key portability. And in terms of the actual use case, the user can swap their lost phone for a new device, another phone, for example, a hardware wallet. They can add a passkey, and also allow other signers to perform the actions for them, like, for example, right now, the AI agents. Second of all, the interface freedom. The Safecore SDK and the 4337 pack allow any UI to connect to the same Safe account. What we have in the Safecore SDK is the protocol kit, starter kit, API kit, React Unity hooks. And basically, the front ends can, regardless really of the platform where they live, can create, sign, execute same transaction with a really short code snippet. Second of all, we also have the Wallet Connect support combined also with 4337, which, like, regardless of which app is using, is allowing the user to use their same account across multiple different applications. Then the data freedom, and this is where the modularity comes in. The modules and guards basically are exporting the rules that are set for a specific Safe account. And you can list them with get modules, get guards. Apart from that, the team is currently working on the new version of the contracts, 1.5, which will also combine the modules and guards together. So guards will be basically like built into the module structure, which will make it easier to implement. And what you can do with that, for example, set spending limits, define the time locks, enable social recovery logic within the same Safe account. And then any UI integrating Safe accounts can read these settings for a specific user. And lastly, something I didn't mention before is the cross-chain freedom, which is basically enabled through the deterministic deployments, counterfactual addresses. And you can find that in the multi-chain deployment guide in our documentation. And basically what it allows you to do is to pre-compute the same Safe address on several networks, so that then other UIs can map it one to one. More examples in terms of different flows when we talk about like the game sign up with a passkey and then going into a DeFi dashboard. What you can do as a builder is basically use the starter kit, enable a passkey signer, and import the same Safe through the protocol kit from the SDK. Another example, sponsored mobile onboarding. Here we go into 457 user operations. You can use the relay kit, which is using, for example, Gelato pack that is paying the fees. And then the same safe account remains valid in any other app that might not be, for example, gas-free. Then, managing cross-chain treasuries. You can deploy the deterministic safes with a multi-chain guide across multiple L2s. And then the solution that allows you to read those balances from different networks is the API kit. And lastly, we have the social recovery that can be enabled by the social recovery module. Users can then add guardians to their account that will be the players allowed to recover the account. And the toolkit that you have here are the modules and as well the protocol kit. That's it from me. Let's build doors, not cages, and let's allow users to have a smoother experience and not have to create hundreds of various accounts, storing hundreds of different seed phrases, and having a more smoother experience. Thanks so much, everyone. Any questions? Mm-hmm. Can you grab the mic? I think it's working, no?
111. Okay. So you mentioned the new version of the safe contracts being in development, the 1.5.0, and that in this case the guards will be integrated in the module flow, right? So right now, for example, we don't see a wide adoption of the guards, of the modules, and probably because of its complexity. So to set up for the usual Web3 user, this kind of the configuration that for sure provides a lot of benefits, but still rather too complex to get through and to set up. Do you see it being changing, with this new version of contract interaction, or it's also UI UX improvements on the safe itself?
Do you mean the users as the address owner, or you mean the developers integrating the?
Yeah, the address owners, for example. So because it's not maybe useful only for the complicated protocols with the huge DAO setups and everything for managing the treasury.
I would say this sits on the UX UI side, where we are going to make it easier with the new version of the contracts for the developers, but then what the interface is for the user to set those guards, because I guess you're talking right now about safe wallet.
Yeah.
But these can be defined in any interface where they are integrated and basically showcased to the user to set them up. So it's really what they see, what they have to go through, the friction that we've been talking about. Okay. So hopefully making it easier for the developers, this will be also easier to implement for the end user.
Okay, thank you.
Perfect. Thanks, everyone. By the way, we have SafeCon going on upstairs on the 5th floor. So make sure to join the talks. There will be some announcements and clarifications about what is the current focus on Safe. Thank you.
Hi, everyone. Thank you for coming today. Hi, Guillaume. Yeah, so my name is Luca, for those of you who don't know me. I'm the CTO at Serenita, where we specialize on staking Ethereum. And today we'll be looking into how to protect validators from client bugs using software that we developed and open sourced at Serenita, which is called Vero. So there will be an active part to this workshop as well in a few minutes. In order to actively participate, you're going to need a Linux machine with ideally Docker installed and about 4 gigs of RAM. Like less should work as well, but 4 gigs would be recommended. So let's dive a bit into the background behind Vero, why it exists, what it is, and so on. The reason why Vero exists has a lot to do with something called client diversity. It's an idea in the Ethereum space where Ethereum doesn't want to rely on a single client implementation in order to keep its blockchain going. So the idea is we should have multiple clients that all track the same blockchain. And that way, Ethereum is much safer from these client bugs, because if one client has a bug, we don't want the whole blockchain to stop going. So that's a quick intro to the idea behind client diversity. It's much more important to the whole system than many people think or are aware of. There's a good article by Dankert Feist on his blog or his website, which goes into the importance of client diversity. So yeah, that's a recommended read. So currently, thanks to this whole idea and making it a priority for Ethereum, we have 6 available consensus layer clients and 5 clients on the execution layer, which you can choose from, and you can basically choose any of those. Ideally, that would mean that each of those clients would be run by a proportionate number of the network. So in case of the consensus layer clients, we'd be looking at about 70% of the network on each consensus layer client. And in terms of the execution layer clients, we'd ideally see about 20% of the network run each execution layer client. So that's the theoretical and ideal scenario. The reality is a bit different. On the consensus layer, we see some clients are being used much more than others, especially Prism and Lighthouse, which we see on the top here, are used by a lot of people, probably a bit too many. This picture is not completely up to date, like Lodestar is shown as 0.10%, but it's higher than that, as well as Grandine. But it's like a roughly accurate picture of things. And then on the execution layer side, it's a lot more uncertain. All those orange blocks in the middle that you see, those are areas of uncertainty, so we don't know which clients some people are running. But this situation on the execution layer side has improved a lot since about a year ago. So we are currently in a much better space in terms of client diversity than we were at 1 year ago. Especially Nethermind has made a big rise in terms of adoption. So now that we're in this state where all of the clients are likely used by less than 2/3 of the network, are we out of the woods? Are we good now? Can we stop worrying about client diversity, right? That's the question. And I'm here to say that we really are not quite out of the woods yet because of multiple factors. One of them is the client usage data. Like I showed on the consensus layer side, it's not 100% accurate. There were some changes in the most recent network upgrade, which made measuring this it made it less accurate. Then there's also the fact if a client is used by more than 33% of the network, so 1/3, it can still be dangerous in some edge cases. Then there's also the possibility of 2 clients sharing a very similar bug like we saw recently on the testnet. So if multiple clients share the same bug, they can still get over 66%. And then one more thing is kind of under-discussed, which are failover mechanisms. Many node operators run multiple client combinations in a kind of failover mode, where if one of their clients goes down, they switch to the other one. And this could do the wrong thing, actually, because if you run these two clients and one of them starts following a different chain, you don't necessarily always want to switch over to another client as soon as something's up with the first one, unless you know what's actually going wrong. So that's the failover mechanisms. As a node operator, especially as a professional one with like a responsibility for other people's money, you want to avoid these client bugs as much as you can. But the hard truth is we cannot completely avoid client bugs, right? These are complex pieces of software. They're going to end up containing some bugs at some time. Ethereum is constantly evolving, like clients are optimizing, so there's always some room for bugs to be introduced. But we can reduce the impact of these bugs, and the simplest way to do that is just by pointing by using multiple clients, right? And pointing some of your validators at one client combination, some of your validators at another, and so on. So in this case that we have on the slide here, we have 3 client combinations, and we basically split up our validators among these 3 combinations. The pros of this approach is that if everybody were to do this, we would be in a very good space. So it's good for the network if you do this. It's a simple approach, it's relatively easy to set up, and it still reduces the impact of client bugs. But in this case, if, say, one of these client combinations does have a bug, still like a third of your validators would go offline. So there is some kind of impact, but it's not huge. It's pretty good. Then there's a couple of more sophisticated things you can do to protect the validators against client bugs. One of them is using Vouch, which is a specialized validator client. It's a multi-node validator client, which means that it can talk to multiple clients at the same time. So in this case, it talks to like 3 consensus layer clients and 3 execution layer clients at the same time and combines their output. So if one of them like has a bug, goes offline, it can keep going using the other 2. This software is used by a lot of professional node operators. It's been around, so it's been battle tested. It's a really solid piece of software. It's highly configurable. You can do all sorts of things with it. It's open source, also nice. The only cons I can think of is that it requires its own specialized key manager. So that key manager, which contains the keys, it's not compatible with other software. So yeah, basically Vouch requires Dirk, and the same way, the other way around. And the other con is actually the same as the pro, that it's used by many professional node operators. The reason I mention it as a con is because all of those professional node operators use it, a lot of Ethereum validators use it. And if Vouch were to contain a bug, you would be offline with many other validators, which well, it could just cost you some money by being offline at the same time as they are. And you're basically forced to wait for a fixed Vouch release. You can't just switch to a different client or something. Then there's the other approach, which is called DVT, which stands for Distributed Validator Technology. One of the implementations is from SSV. And with DVT, you basically run a single validator out of multiple places. You kind of split it up. And yeah, so in all of those places, you can use a different client combination. And again, you can this way protect validators against a single client bug. So moving on to the next DVT implementation, which is from Obol. It's called Karen. The high-level idea is the same. So you, again, split up the validator, can use multiple client combinations in each place. In this case, Obol's Karen software has a business source license, and it has a bit of a non-standard middleware approach. So it's, yeah, again, not interchangeable with anything else. So all of these advanced approaches to avoiding client bugs have something in common, and that is that they're kind of their own way of doing things. They kind of lock you into their own ecosystem, and it's hard to switch to this advanced solution. It's also hard to switch back from it. So at this point, the question arises, can we get to the same result? Can we avoid client bugs without all of the complexity? So yeah, that's when I thought we should write a new validator client with some design goals. One of them was that it should be able to talk to multiple nodes at the same time in order to avoid these client bugs. The other thing I wanted to do is keep it simple, which is always good when it comes to software. Security, obviously this is a validator client. It's close to private keys, so you want it to be secure. I wanted it to be observable, so I wanted us to have a good idea of what's happening, when it's happening, why we're having issues, to make it easy to investigate any issues. I also wanted it to be compatible with all client implementations, and one important thing for me was making it compatible with Web3 Designer, which makes it then much more compatible with the rest of the ecosystem. So that's how we came up with Vero. It's succeeded in terms of all of these design goals. It's a multi-node validator client. It's simple. It has less than 4,000 lines of source code. It's secure. It never touches validator keys directly. It's highly observable, and it's compatible with all the client implementations as well as Web3 Designer. So when it comes to a high-level overview, where does Vero come in? So this is an example of, let's say, more sophisticated setup with multiple clients. We have the execution layer client, a CL client, the validator client, and then a remote signer, which is connected to its slashing protection database. So Vero is basically the same thing as all of those validator clients as in the middle. You can just swap it out easily for any of those in this kind of setup. When it comes to Vero being multi-node, that can mean multiple different things, but in the context of Vero, it just basically means that it talks to all of these client implementations at the same time, and it follows the chain based on their combined output. So if we say have 4 client combinations and one of them has a bug, goes offline, Vero is still able to follow the chain that the other 3 client combinations agree on. In terms of observability, it has readable logs that you can follow. There's dashboards for Grafana that you can simply install. The left one is just a high-level overview of what Vero is doing, but it also offers you the ability to dive deeper into at which point in the slot are certain actions taken and so on. Vero also supports exporting traces, so you can really dive deep into this is a block proposal, so in case you miss a block proposal, you can really tell at which point it actually went wrong. One novel feature that Vero has, and that has only recently been started to introduce in other clients, is slashing detection. Vero listens to slashing events happening on the entire network, and if it detects any slashing event for a validator that is managed by Vero, it automatically shuts down its validator duties. So that way it prevents further validators from being slashed. This is what it looks like on the dashboard. So this is under normal conditions, no slashing detected, it's performing duties. And as soon as any of its validators are slashed, it stops all activity. So with a new validator client, some people are worried about its performance. Vero currently powers thousands of validators, so we've made sure that it performs well. And we're currently among the top on Ethereum in terms of validator effectiveness as well. So if you're worried about Vero's performance, you don't necessarily need to be. In terms of risks, I've talked about the good things about Vero, but maybe there's some bad things too, right? I try to be objective here. There's a few possible vectors that you could be looking at, like slashing, but Vero uses the battle-tested slashing protection that Web3 Designer uses, so that shouldn't be an issue. There's also the slashing detection feature that I mentioned, so it's kind of better in some ways in terms of slashing protection. In terms of validator key compromise, Vero never has access to validator keys, so you don't have to worry about Vero leaking those. In terms of bugs, obviously, every piece of software can have bugs, but this is a small code base. It has high test coverage. It's very simple, like I mentioned, so that should hopefully help us avoid bugs. There is no lock-in. You can very easily switch to a different validator client at any time. And in terms of downtime, yeah, I mean, it's possible that Vero has a bug which leads to downtime, but in that case, you can just switch to a different validator client very easily. One more question, is Vero for professionals only? It's not. You do get most of the benefits if you run it with multiple beacon nodes and so on, but you can also just run it with one beacon node, one client combination, so easy enough. Nixo wants to ask a question. Mihika, could you pass the microphone? Thank you.
You said you could use it with one machine and one client combination. Why would you use Vero for one client combination? Is there an advantage there?
If you like Vero's metrics, for example, they're more detailed, I think, than other validator clients for the slashing detection feature, which some don't have yet. So there are reasons to use Vero even with a single client combination. Yeah. Okay, thank you. Any other questions so far? Okay. So yeah, there's a lot of good things about Vero, not that many bad things, so I would encourage you to try it out. In terms of what's next, we're working on supporting the next network upgrade and also considering adding doppelganger protection. The end goal is basically for people to start running Vero in these kinds of setups where they use a lot of different clients around Vero, and that way they have a lot of different clients' view of the chain that they can use to make an informed decision on which chain to follow. All right, let's move on to the active part of the workshop. So has anybody in here set up a machine that they can use? So we have, yeah, what about you, Guillaume? You're gonna join the active part? If it requires Docker, no, but otherwise yes. Okay, it requires Docker, so just follow me then. Okay. So Luca, in case you want to follow it, this is a website which lists all the commands that we're going to be using, so you don't have to manually transcribe. This is what it looks like. So you just go to workshop.serenita.io and you can just copy paste the commands. So we're going to get started with this. Oh, right, one more thing. This is a high-level overview of the setup we're going to be using today. So we're going to be using 3 execution layer clients, 3 CL clients, and Vero with the remote signer. But to set all of this up today would be too much work, so we're going to start off by only setting up Vero. And I've already set up the rest of the infrastructure for us. So it's time to begin. The first command that we're going to run is this one. It basically starts Vero and points it at the beacon nodes that I've prepared. So yeah, let's do that. I'm gonna copy the first command. And let's paste it in here. And what this does is it runs the validator client on the Hudi network. It uses this remote signer, and then it uses these 3 beacon node URLs. And the last thing is just the setting the fee recipient, which is required for Vero to start. Okay, almost. I'm gonna need sudo here. So it's gonna pull Vero's image. All Okay, and we are basically live. You can see the first slot ticked off here, and we already published some attestation here. It's as simple as that, if you already have the beacon nodes running. Yeah. So yeah, you just need the addresses of the beacon nodes, a remote signer, and that's it. How are you doing, Luca? Yeah, it's working? Yes. Perfect. Okay. All right, so that's not the end of the workshop. This was the simplest way to get like Vero running, right? If you only need this single piece of this architecture, then it's pretty simple. We're gonna go one step further than that today.
But I got a question before we
okay.
So now we have run the same command, and so what are you using to not slash us? Just remote signers slashing protection database or something else?
Yeah. So these are the logs we've seen, and that's what I wanted to mention. We're all using the same validator keys because we're all using the same remote signer, and that remote signer has its own slashing protection database, exactly. So even though we're running the same validators, we're not going to get slashed because there is a slashing protection database in place. So yeah, we could get into a point where we try to attest to different things, but because of the slashing protection, one of us would fail to do that. All right, you can now stop the process. It'll take a few seconds to stop because Vero has this shutdown mechanism where it waits for any pending duties to be finished. All right, so in this next part, we're gonna go one step further. Besides Vero, we're also gonna spin up the remote signer and its slashing protection database. So the next commands to run are basically, we're gonna be using eth-docker to do all of this to make things easier. So we're gonna clone the eth-docker repository and yeah, make some changes to it as we go along. So we're gonna run git clone. Oh, this one. Change into the directory. We're gonna make a copy of its default environment file. And then we're gonna make some changes to this file. I'm gonna be using Nano here, but you can use any text editor. And the changes that we're gonna make are the following ones. So we're gonna change the value of the compose file. So it's this one. And we're gonna need to set the fee recipient value. The network should already be set to hoodie, so we don't need to change that. We need to enable Web3 signer, which is right here. True. And then there's one more thing. We need to change the CL node setting. So that's the one that points Vero to these different beacon nodes that are already running. So that one's all the way down. Where is it? Here it is. So we're gonna remove the original value and paste the new value. And I think that's it. So we set these. We're gonna save the file. How are you doing, Luca? All set? Yes. Okay. So now that we have changed the environment value, we can bring ethdocker up using this command. This will take a second as it downloads some Docker images again. So we're working towards this, setting this up, Vero and Web3 Signer.
How do clients updates work? Do they get pulled automatically, or do you have to wait for Vero to incorporate them or anything?
They work automatically. So ethdocker automatically pulls the latest version. So as long as Vero tags something as the latest version, then ethdocker will automatically take that. Still waiting for some images. You done, Luca? Also waiting? Okay. If anyone happens to be watching online, maybe you can send me a message if you want to actively participate, because you're going to need a special thing soon. So you can DM me at Serenita_Luca, L-U-C-A. Still pulling here. It could be specific to what ethdocker does. It likes to build its own images. Even if there's an official image, ethdocker builds its own version. Sometimes. I think it has sometimes changes permissions and stuff like that. So yeah, as you can see right now, it's using the Web3 Signer base image, and then it's gonna perform some other things on top of it.
Right. Okay. Now I have to use a mic. Why? But yeah, it's the Web3 signer itself that's taking, that's downloading and rebuilding all the layers, or is it just that the network is slow?
The network is a bit slow here, I'd say. Yeah, that's
okay. Okay.
Yeah, but also Web3 Signer is being built. I see it in my logs. So
okay.
Yeah, but
and Web Signer itself is very big
Gotcha.
Docker image, if I remember correctly.
Okay, understood.
a lot of these Docker images are a bit bloated.
Yeah, that's fine.
But it looks like we're almost there, so. Did you manage to build yet, Luca?
Yeah, exporting, so I'm pretty much done.
Okay, looks like I'm done too. So Ethocker is spinning up all of these services. This looks like it's done. So at this point we ran eth_d up, and now we can run eth_d logs to check the logs from the validator service. So if we do this, we can see Vero starting up. So these are all the. It's a little hard to read. Let me just make it a little smaller. Hopefully this is still big enough. So yeah, it's started up, and the only thing we can see is that we can see some warnings in the logs which say that there are no active or pending validators, so it's actually not performing any validator duties. Like the validator client is running, but it's not doing anything because it doesn't have any validators attached to it. So that means it's now time to, we already did all this. So yeah, we're seeing these messages warning us that duties are not being updated because there are no active validators. So we're going to be adding some keys now. We're going to be using these magic numbers here to import keys. And yeah, that will, we will import validator keys into the Ethocker setup, and then Vero will perform the duties that those validators should be performing. So it'll look somewhat like this. We're gonna enter a magic number here. I'll give one over here. This is your password. So this magic number will allow you to download some validator keys. So if it downloaded successfully, you should see like this kind of output. If you see an error like this with a 404 status code, then it didn't download successfully. Did you manage? Yes. Okay, perfect. So now we have a zip file that contains all of these keys. We're gonna extract the keys into the correct directory for Ethocker using this command here. So you should see the zip files being inflated. And next we're gonna say eth_d keys import. And this will import all of the keys that are located in that in the directory that we just extracted them to. So this will take a minute. And at this point, Ethocker is asking us, these are warnings, yeah. If you're gonna do this like for real, you should read all these warnings. But yeah, it's basically saying, it's warning you if you've used these keys before, make sure that you turn them off and that you're using slashing protection database and so on. So we understand these warnings, we say yes. In this case, all of the validator keys have the same password, so we're gonna say yes. And we're gonna enter the password, which is just workshop. So Ethocker is gonna be importing all of these validator keys now. We're at this step. So at this point, all of the validator keys have been imported. We're gonna run eth_d, I think it's restart, yeah, restart validator. That will make Vero refresh its validator keys. And if we now run the logs command again, Then we're going to see Vero's logs, and we're going to see that those warnings are no longer there. It's not warning us about anything anymore. It's actually updating duties now, and you can see already some attestation has been published here. So it seems to be working for me. How about the other Luca also? All good? Perfect. So yeah, that's the logs. We can also like dive into metrics, but it's a bit more complicated, and I don't want to keep you too long before the panel with Vitalik. So I'm gonna like show you how it's done, but we don't need to necessarily go into the details because it also uses some other Docker images, so we'd be just like waiting for a while. So the way it works is you add Grafana to your eth-docker compose file. You adjust the share IP in order not to share Grafana with the rest of the world. And then you just run eth-d up again. It will pull some Docker images, and at some point it'll be done, and then you can open localhost at port 3000 in your browser, and you'll have a Grafana spun up, so you just log into that. The default credentials are admin, and then you click on dashboards, and you'll find the Vero detail dashboard. You select which instance you want to follow, you adjust the time frame, and you basically get these nice charts that show you how Vero is doing. Yeah, for anyone interested in traces, you can like talk to me, and I can show you like what those traces look like. It's not possible to set it up as part of eth-docker right now. So, okay. Do we have any more questions?
I didn't get the part with the traces. So if you can't get them from Docker, where do you get them from?
eth-docker doesn't have any any endpoint where you can send traces to.
Right, but so clearly you can extract them because you can show them. You said so. How do you extract them?
You just add an environment variable to Vero. That contains the endpoint where it should send traces to. Yeah, and yeah, we use Tempo for that. But yeah, Tempo is not part of the eth-docker stack right now. So. All right, that's all for today. If you want to learn more or keep in touch, these are some contact details and locations where you can find more information. Thank you for coming, and I also saw that Ladislaus is watching online, so hi. That's it for today. Thank you, everyone, and yeah, bye.
Okay, thank you everyone for joining us. Today we're going to talk about Balancer v3 hooks and how you can build on them and why you should build on them. Just a quick intro to the agenda. We'll do a very quick v3 introduction, talk about why it's good for you guys to build on Balancer and some of the benefits that you maybe don't know about. A quick overview of the v3 architecture and how that relates to hooks. We'll go through the stable surge hook, which is a hook that is deployed live at the moment. That'll showcase some of the hook code. And then I'll switch to Fabio, who will walk through another one of our hooks, which is the MEV capture walkthrough. And then we'll close out and you can ask any questions. So Balancer v3 is a platform for AMMs. Using our past experience from v1 and v2, it was really focused on making it easy to build and customize AMMs. It's been fully and very deeply audited, been audited by 3 of the best firms, which should give you confidence that you can use it as a Lego block to build on top of. Some of the other interesting innovations that we added is support for 100% boosted pools, which basically makes the pools super capital efficient by depositing idle liquidity into any of the lending protocols such as Aave. And for this talk especially, we introduced support for hooks at various lifecycle points. And these are basically modular plugins that allow you to extend any existing pool behavior. Since launch at the end of last year, both partners and ourselves have been busy building things on Balancer v3. We've got a range of pools that have been built on top of it, such as weighted pools, stable pools, gyroscope pools, which were built by the gyroscope team, quant AMM pools, reclam pools, which is our latest pool that Fabio introduced yesterday, and LBPs. We also have 3 hooks in the wild as well, the stable surge hook and the MEV capture hook, which we'll go over today, and an Acron hook, which was built by a separate team without even really getting in touch with us, which kind of showcases how easy it is to do. So the question was, did cow AMMs also build on top? So they're actually built on v1 because they were developed while we were still developing v3, and they will be ported to v3 at some point soon.
They're doing that as we speak.
Because the v3 contract repo has the cow pool in it.
The v3. That's possibly part of the development that we're like migrating over now. But yeah, it should be coming soon on v3 as well. Yeah, so why should you guys build on Balancer v3? The main reason is actually because you can take your idea to a product super fast. And a shorter development cycle means faster time to market for you. And you can just focus on implementing your actual idea. You can build on top of all the Balancer audited code relating to like token balances, accounting, and you can just take care of your own stuff. We also have comprehensive documentation. We have a range of example hooks and reference implementations in the monorepo. We've got a bunch of helpful periphery contracts that you can leverage for testing and development. We have very active dev support in Discord and Telegram, and we also have grants available if you have new ideas. So basically, if you have anything or if you need help, you can reach out to us at any point and we'll be there to help. And it's not just the development part, we also have a lot of support after launch or before the launch through our ecosystem. We have the Balancer front end, which is modular and easy to update to include customer branding. We can also implement like extra features, so both Gyroscope and Quant AMM are separate products, but we've managed to like add them to our Balancer UI, which allows them to launch straight away with an interface that LPs can come and add and remove liquidity. And it also showcases like their own kind of design, their own kind of like graphs and things. Aggregators is super important. You can't just launch a pool and expect the aggregators to pick it up. We have like good relationships with like all the core aggregators and solvers. And we also make contributions directly to their code base. So that's something that we can do so that you can launch and soon after be picked up, which drives volume to your pool, which gives your LPs more swap fees. Balancer also has the incentive flywheel, and we have a very capable and like supportive operations and marketing teams. They can help you from things like governance proposals, launching your first pools, anything like that. There's somebody there to kind of help you. So just to cover the architecture before we get into the code, it's a very high level view, but there's like 4 main components to look at: the router, the vault, the pools, and the hooks. The router is the user's entry point to Balancer. And this is where like somebody would go if they want to register a pool, add liquidity, remove liquidity, or swap. The vault is a singleton contract that handles all the token scaling, fee accounting, limits, things like that, and it's been optimized for gas. Both these contracts or range of contracts are fully audited, deployed, and it's not something you really need to worry about. You just need to focus on the right-hand side, which is your custom pools or your custom hook logic. And it's probably worth explaining at this point the difference between the pools and the hooks. So pools are where you can define your core maths. It's where you can build different math-based liquidity curves. So you can think of your weighted pools, your stable pools, gyro pools, things like that, basically giving you custom pricing model. So it's like a new AMM. Whereas hooks extend these pools. So a hook can be used with any pool type. It can be used with multiple pools, and it basically allows you to build extra behavior on top of that existing pool. And a hook is registered with a pool when the pool is created, and once it's registered, you can't unhook it, basically. It's immutable, so that's something worth knowing. And the hooks themselves can be hooked into like a different range of lifecycle points. So we have basically registration, initialization, after and before add liquidity, the same with remove liquidity, and we've also got the dynamic swap fee hooks. And you can use one or more of these within your hook. So the hook stable search hook, this was an innovative directional fee mechanism that was actually proposed by one of our maxes. And it's basically a dynamic swap fee hook that as the pool becomes imbalanced, the price of the swap fee goes up, which should protect stablecoin pegs during periods of market volatility. And the things that we use in the code here is a stable pool and also the custom surge logic which exists in the hook itself. To start with, we'll talk about 2 of the periphery contracts that exist in Balancer v3 already that you can leverage. So the first one is the Vault Guard. It's a base contract that your hook can inherit. It stores a reference to the Balancer vault and basically ensures that when you use the only vault modifier, it restricts access to only the vault. And it's important to use that because only the vault should trigger hook logic. And this prevents external or unauthorized contracts from calling any sensitive logic. You can just flick over quickly. Just looking at the stable search hook itself. So you can see that it's added here on the on register. And it's easy to just import this. And you just inherit it as the Vault Guard. And these hooks are all available in the monorepo and serve as like super useful references if you're going to start hacking yourself. The next one is the base hook. It's another one that can be inherited and basically implement a minimal default hook that your hook should follow. You can basically override any of the functions that you want to implement and then be sure that anything that you have not implemented will be covered correctly. That's basically done by each hook returning false, which means that no logic will be applied for that hook. And you should use that for a number of reasons. It basically saves you time because you only need to override what you want to do. And it does ensure that your hook is going to be compatible with the interface. And it basically improves your safety. I'll just quickly show that one. So it's the base hooks here. And you can see that every hook here is just defined and returns false, which basically shows the vault that that hook is not going to be used. And then in the stable surge, wherever we want to use any logic, we've just overwritten it here and implemented our own logic in the contract itself. So the first thing that you have to override if you use the base hooks is the get hook flags function. This is called by the vault whenever a pool is registered, and it basically tells the vault what the config of that hook is and what hooks it's going to use. Once the pool is registered with that hook, that config is saved in the vault, and the vault will use those configs to make sure that the hooks that you've configured are going to be used. And we can see in the stable search hook that we use 3 separate hooks. We've got the dynamic swap fee, the after add liquidity, and the after remove liquidity. Every hook must implement this, and if it doesn't, your test won't pass, basically. On hook registration, we also have the on-register function, and this can be used for a bunch of different things. One of the common use cases is restricting usage. So basically, if this function returns false, the action will throw and the pool can't be created with that hook. So you can use it for whitelisting. You can restrict it to like certain pool types or certain pool factories. And it can also be used to like initialize with like default configuration. For your pool to successfully register with a hook, that function must return true. And we can see in the stable search hook, there's no kind of whitelisting going on, but it's been used here to set the max surge fee to the default and set the surge threshold to the default. It also emits an event, which is super useful for the off-chain infrastructure, and then it just returns true, which allows the registration to continue. The other hooks that this particular stable search hook uses is the add and remove hooks. So these are triggered after an LP adds or removes liquidity. And it's important to note that this function gets called with the updated balances from the vault for that pool. So it can be used to validate the pool state. You can emit custom logs or analytics. It can also be used to, like at that point in time, to interact with external contracts. And in this particular case, it's used to detect if the pool is surging at that point after the liquidity has been like added or removed. And if it is surging, then it'll throw false and the action will be blocked. And this ensures that the liquidity isn't added during unstable conditions. It's a pretty hard one to see. So. If we just look at a bit of the code here, we can see the first thing it does is it's checking what kind of add action it is. Any proportional add is fine because it's always going to be adding it proportionally, which won't unbalance the pool. So it immediately returns true, which allows the vault just to continue with the action. If it's not a proportional add, then we're doing some maths to basically detect if the pool's going to surge after the action. And if it is surging, then it returns false, which will block the action. And if it's not, it'll just return true. So it's a nice way to make sure that your LPs aren't going to get like shafted, basically. And then the last one, which is where the meat of this like innovation is happening, is the dynamic swap fee, which is the on-compute dynamic swap fee percentage hook. This is called every time that a swap is happening, and the hook responds to the vault with the current swap fee, which is then used in the swap calculations. And this allows your hook to dynamically change the swap fee based on the pool state, the direction, or like external data. So there's a lot of room for innovation within this. The dynamic swap fee itself, the maths is here. It's pretty detailed. If you do want to look at it, you can check out the whole like monorepo implementation. But the basic kind of principle is if the pool drifts from the balance, the fee starts surging. It increases the fee as the imbalance becomes further. And if it's not surging at all, it'll just return the default swap fee. So you can see this So here's the one, compute dynamic swap fee. It has to return true again. If it turns false at any point, then the action will be blocked. And then it's again the get surge fee percentage. So the first thing it's doing is updating the balances with the amounts, and then it goes into the get surge fee percentage. This is where the maths is happening, and then it's basically checking if it is surging, it returns this calculated swap fee, which is based on the maths, and if it's not, it just uses the static swap fee that was the pool was configured with at the time. And the reason we wanted to kind of highlight stable surge is like this is a hook that was implemented in probably about a month, including audit time, and it's a hook that's in the wild already. It's deployed in mainnet and L2s, and it's powering a lot of our like partner stable pools. It's already got over 30 million TVL and 100 million swap volume. There's also like a couple of links to the full contract code, and also a blog post that kind of shows the whole deep dive into the concept and how we went from like design to the full product. Yeah, and that's us. Pass you over to Fabio.
Any questions so far? We have the microphone there. Yeah, a question.
One, okay. So thank you for the explanations. The question is, the hooks, are they just smart contract functions, so to say, or is there anything, any tech stack on top of that, such as, I don't know, oracles, maybe some cross-chain stuff, or maybe some monitoring nodes, monitoring something that trigger some of the hooks?
No, they are just standalone smart contracts that the vault is aware of. So the vault calls those smart contracts at those specific points of time in the pool life cycle. So like if you think like the LP is going to add liquidity, when that action is triggered in the vault knows that that pool has an associated hook and calls out to that contract, does the logic, and then returns back into the vault, which will then continue. But you could like, from your hook, you could reach out to like other contracts as well. So it's like an opportunity for you to do that.
And when you say the vault triggers the action, does it happen when a user does something, or does it happen at some time intervals, or maybe the protocol itself triggers the vault?
Probably best to show you. So it's these specific points here, which are all related to like a pool life cycle point. So we have like the registration point. So when a pool is first registered with the vault, you can do like an action before and after that. When a pool is first initialized, which is like when somebody first adds liquidity to it, the same again you can do before and after, and then also before and after add liquidity, and then the dynamic swap fee percentage is whenever there's a swap. So it's those kind of core actions that you can like inject your logic into, I guess.
Yeah, understood. Thank you.
Cool.
Okay, I will continue. We have a second hook to present today, which is the MEV capture hook. This one is a quite simple one, but powerful at the same time. So the objective of this one is to internalize the value leaked from the pool to the liquidity providers, and then redistribute that value loss in between the liquidity providers who have been providing liquidity for a long time in the pool. Methodology is actually based on a paper from Paradigm called Priority is All You Need, if you have read it. And we use priority fees to identify which transactions are from MEV bots. So with that information, that's the signal we use, we apply a dynamic fee mechanism which aims to internalize the most value possible from the arbitrager. So this is more or less how it works. So here on yours left side, we have how it works today. And I did not mention actually, but this only works on op stack chains. where you have priority fee, a centralized sequencer which sorts the transactions by this priority fee. And in the first image, you have the arbitrageur, and on the right side, you have the validator. How it works today is the validator receives this fee and sorts the transactions by the priority. And if the arbitrageur manages to perform this arbitrage, it receives the profits from the liquidity providers, from the validator. On the other hand, what we are trying to do is adjust the swap fee of the pool based on this signal, based on the priority fee. So you can try to keep the most value possible within the pool and not send that over to the validator, to the base sequencer, for instance, or on any upstack chain sequencer. And that value will be redistributed automatically for the liquidity providers, because this can be applied to any fungible position or any balancer pool, actually. So you might be wondering how you get the priority fee from the block or for the transaction metadata. That's actually not directly available, but you can calculate it. So we have this object transaction and this other object block, and in each one of those, in the transaction you have the gas fee, in the block you have the base fee. And actually, that's combined, that's the fee that's been paid by the user, but if you subtract one from the other, then you have only the priority fee price paid by the user. And that's what we are going to use as a signal for the dynamic fee calculation. We have a few hook params. That's how we are modeling the problem, and that's how we're going to apply the dynamic fee. So first of all, you have a threshold, or we decided to have a threshold, and that's the threshold that determines when you start triggering, when you start charging priority fees. We don't want to charge priority fees from solvers, aggregators, and retail users. So we have this threshold in order to distinguish between retail flow and arbitrage flow. We have the multiplier, which means how aggressively we're increasing the fee based on the priority gas. We have a max swap fee percentage. That's a global maximum dynamic swap fee. That's mostly for safety reasons. I guess you can just go over and over. And then you have the exempted senders. Again, speaking of the same idea as for the threshold, we have contracts that we trust that the only flow that's coming from there is retail flow. So we could, for instance, trust the call swap settlement contract and just apply the static fee for them, because we acknowledge that the flow coming from the order flow coming from their contracts, it's just retail flow. It's good flow for the pool, actually, and it's what makes the LP providers making money. This is what the hook setup looks like. So we have on register, on before add and remove liquidity, and you have on compute dynamic swap fee. As John showed us, we have the get hook flags, which defines exactly what is said. So setting true for this for these three hooks, default should call. And then upon registration, this is the simplest one. We just have this default multiplier and the default threshold for all the pools, but that's actually also configurable upon registration. The pool owner, the swap fee manager, can actually change that. You might be wondering why we need the before add and remove hook, and that's actually needed because that transaction or that operation can behave like a swap, because at Balancer V3, you can do unbalanced operation. So I can single side join a pool and single side exit that same pool. That's pretty much a swap, and we have to protect against that case. So that's the reason we have this before add and remove. If the kind of the operation is proportional, that's completely fine. That's just someone joining the pool. But otherwise, we'll check if the priority gas price is below the threshold. If it's above the threshold, that transaction will just revert. we will not allow the liquidity provider, likely being in this case an MEV bot trying to arbitrage that pool, we will not allow that. And then the most interesting logic is really the dynamic fee. One thing that I already mentioned, and the first thing that happens on this transaction, on this function, is we check the sender to see if it's exempt of the MEV tax or not. And in order to do that, we have to use this trusted router function, because anyone can call the vault, and anyone can tell the vault or can tell the vault that someone is performing the swap, even though it might not be that person. So we need that sort of routers that we trust that are going to pass us the original sender, the user, the retail user behind that transaction. So that's why we use this concept of trusted router. That's the second thing we check on this function. If it's a trusted router, we get the sender, and then we check if the sender is one of the exempted MEV tax addresses. If that's the case, we just apply the, go ahead, can you pick up the microphone?
So I understood that maybe something like these aggregators would be exempt. You're using the whitelist for that. Do you set this at the pool creation, or like how do you leave it open enough to adapt, or I don't know?
Yeah, that's controlled by the DAO. So we have this contract called balancer registry, and then we can whitelist addresses there. So far, we have only whitelisted the cow settlement contract, because that's the one that is for sure retail flow. There are some aggregators that anyone can call. You don't have this enforcement, the batch auction that happens at CowSwap. So we did not allow listed any other aggregators, but we did it for Cow, and that's on the DAO's permissions. The balancer DAO did it, yeah. Actually, the max is on behalf of the DAO, which is a service provider.
Can the pool deployer like configure their pool in a way to be the controller of this allow list, or is this?
I don't think so. The way it is set up right now, I don't think so. That's for DAO.
So how much freedom do the pool deployers have to govern the mutability of their pool after the fact, and how much of it is on balancer side?
It really depends. It's case by case. I would say the pool owner here do have the ability to set multiplier, set threshold, and some of the params, but they do not have ability to set it all. That's a pool type developed by Balancer. That's what we thought was the best when we were designing, but it could be even changed. Sounds good?
I'm not complaining.
No. No worries. Cool. Yeah, that's it. That's the beginning of the dynamic fee calculation. And then we go to the function itself, the function that's called by the hook. That's the calculate swap fee percentage function. The first thing it does is get the priority fee gas price, as I showed you guys. If it's below the threshold, we just return the static swap fee. There's nothing to be done. But if it's above the threshold, then we take the difference from the priority fee gas price paid by the user minus the threshold, and we multiply that by the multiplier. So that's how we do, and that's how we get the fee increment. So this multiplication will give us the fee increment that we have to sum with the static fee, and that's the fee that will be ultimately charged by the pool for the arbitrager. We do have a cap, as I mentioned before, so we have this max swap fee percentage. That's why the return of this function is actually the minimum, either the max or the new swap fee percentage calculated by summing the static swap fee and this fee increment. Just wrapping up, we have deployed this pool, I guess, 1 or 2 months ago. It was the first of its kind MEV internalization product on Base, and it also expands Balancer MEV protection toolkit. We had Cow AMMs, built on Balancer V1, and live on mainnet and Gnosis, but now we also have this other product live on Base, and could be live on other OpStack chains, as I said, but we're focusing on Base right now. So pools available on Balancer V3. You can find them on the UI. There's a filter there. You can find MEV capture, and you have the contract code. The Solidity implementation is on GitHub under the Balancer V3 monorepo. That's it. Speaking of the MEV capture hook, you got a question for the MEV cap?
If it's question time, I can wait.
No, go ahead.
Okay, so maybe this is a long-winded question, but we're seeing a lot of like launch pads, I don't know, pump.fun and all this stuff out there now. And a lot of them tend to use UniV2 pools because it's super easy. And we see people maybe launching, I don't know, UniV3 pools. And it's obvious, at least to me, that Balancer would be the way to go when deploying liquidity, because you have some additional configurability or something. But I guess my question was, what configurability does Balancer V3 offer? Like, I mean, we see the hooks. On top of like all of these commonly used alternatives that like give incentive to, say, the pool deployer to use it instead of something super trivial like UniV2.
Mm-hmm. But you mean the pool deployer as a developer, a builder, or someone who wants to launch a token?
This is somebody's like got a launch pad to launch a token, and like at some point, once this ICO phase is over, the liquidity that's been added to the launch pad gets added. It gets deployed to a pool that's like, say, technically owned by the launching, whatever address is associated with the ownership of this company, this entity, and it's maybe, say, locked for years, but like maybe the DAO wants to have additional, like the actual token holders of the pool that's been created, maybe want to have some control over like changing these parameters over time.
Okay. Yeah, I guess we are right now working on LBPs, so I guess I'll start from that. So we are taking LBPs, the liquidity bootstrapping pool, from V2 and porting to V3. That's a pool designed for launchpads, actually, launching tokens. And what we're trying to do better this time, I would say, is having post hooks for LBPs, such that you have some guarantees that after the LBP runs and the sale of the token happens, migration can easily happen for a new Balancer pool. You have some insurance that maybe liquidity will be deposited, locked, tokens burn, like you have on pump.fun, for instance. So we are really into this post-hook LBPs research. Balancer V3 does offer a lot of flexibility for projects to do whatever they want, I would say. We do have our own pool types, which, like, you have defined params, like you have a weighted pool which has weights and a swap fee. You have a stable swap pool which has tokens and a factor. That can be configured by the pool owner, by the way, if he chooses to do, but he can also, afterwards, after deployment, the pool owner can do that for sure, if he chooses to be the pool owner, kind of, because that's one of the params of the construction of the pool. You can delegate that power to the Balancer DAO, for instance, or even to any contract, really. or you can keep it for yourself, or you can even burn it, maybe like set to a random address, like the DAD address, and that's it. Nobody will be able to change it anymore. It will be immutable. So yeah, balancer.
It's probably worth saying as well that we also have like quite a comprehensive like operations site as well that makes it easy for people to manage the pools, create like payloads and things like that. And the maxis always like support people through that as well.
Yeah, just a quick one on your question. One other thing that happens is Balancer has always been, I want to say, shy on shouting out like our benefits comparing to other competitors. And that we can see every time that we talk to a partner and then we show them how good our pools work and how easy it is to create a new pool, and how they can tweak the parameters when they're starting it, and how different pools we have for each type of strategy. So one of the things that I would mention here is that besides only being easier to use, we're focusing also on shouting out a little bit more on these capabilities. And I think when we launch LBPs, that will be kind of like a no-brainer or easy sell to show how good and how easy you can just switch to a pool. And then even like after that, let's say you go with a reclam that he presented yesterday. If you're not happy with the parameters, you don't need to migrate to a new pool. You can just change the parameters. So those are like a few tweaks and things that we can show that. Yeah.
So I was under the impression that these bootstrapping pools already existed even in V2. Is that not a thing?
Yeah, it's live on V2. We're taking and porting to V3.
Yeah, okay.
And relaunching and bringing to the Balancer UI actually, because before we had this external UI running LBPs and we were bringing LBPs home.
Okay, so I mean, people who are doing launchpads shouldn't be rolling their own contracts anymore, like at all.
Yep.
Yeah, exactly. They won't even need to do a UI because the UI on Balancer will support it as well.
Yeah, wow. Balancer's great.
It's also a great opportunity for launchpads because we're providing the infrastructure. You'll have access to what's happening on our UI, but we'll not be promoting the token launch UI as Pump.Fund does. So we're actually just going to promote our infrastructure that you can use. People can use the contract by themselves, by their own product, but if someone wants to create a UI and create a launchpad and use our protocol, that is fine as well, and they can use all the structure that Balancer offers on their own UI.
They could potentially make money off that as well. I think that's something we forgot to mention maybe. But in Balancer V3, we do have a pool creator fee. So upon registration, you can set a pool creator and take your cut of the swap fees generated by that pool. So there's an easy model for builders and developers to, yeah, just make money building Balancer. Thank you for the questions. Yeah, moving forward, last slide, I guess. We have a few grants up for grabs. This is all hooks. Yes, this is all hooks. So we have been revamping actually the grants program. I'm leading it right now with Mike B. He's not here, but he's my partner. And we had 3 ideas that we would like to see built on Balancer V3. First one is size-based fees, so charge different fees based on the volume that trade is producing. That potentially involves some integration with oracles or something like that, because you do have to have a notion of price in that case. We have permission pool. Some kind of projects have already reached out to us asking for a solution to have permission swappers or liquidity providers. There are many ways to build this actually. You can use attestations, you can just hard code a bunch of addresses on your contract, but yeah, you have to come up with a good and scalable solution. for this problem. We're just throwing a few ideas out. And then the last one is directional fees. So that's the idea of liquidity providers being able to adjust their spread based on the price of the token and the volatility of the market. So that's the third venue for exploration. This all can be done via hooks, specifically dynamic fees, 2 of them. The permission pool would be on before swap, on before add remove liquidity, as you have to check the sender. You probably have to use the trusted router, as I was showing you guys. And yeah, those are our 2 ideas. That's my Telegram. Feel free to reach out to us. It's the first time, I guess, we're talking about these ideas, but we'll probably do a push on Twitter. You might see that there as well. But yeah, feel free to get the alpha and reach out to me if you're a builder and want to do that.
So what's the process to participate in these grants? Do we put up proposals in a forum first, or do we just start forking V3 contracts?
No, talk to me first. Reach out to me. We need a proposal for sure. That proposal does not have to go to the forum. We have a grants committee, and you can submit a proposal to us. We don't have a clear format, I would say. It's more about like getting to know your background, what your proposal in terms of deadlines and ask in terms of budget looks like, and then we'll set up a group and chat and figure out. Do it.
Yeah, so in terms of this grant program, are we supposed to build purely on your stack? Because the ideas I'm getting is applying our infra tech stack to your hooks to possibly enhance the functionality.
I did not get it.
Yeah, so the question is, are we supposed to build purely on your tech stack, or can we add something else on top of that?
You can for sure. Like as I said, the size-based fees can be probably built on top of Chainlink oracles. For the directional fees, you might need some sort of pricing data as well. For the permission pool, it could be on top of attestations. You might have heard of it, but yeah, it's built by the AIS team. But for sure, if your tech contributes to any of those problems, right? Like those are problems we have. We want to find solutions to them. If you can help us figure out, I guess that's great.
Is it the full list of the problems? Are there some open?
These are the 3 we're putting out there. I actually managed to just have this short list of 6 yesterday, but I prioritized those 3, just a smaller one, easier to scope. We don't want to create like huge projects at the same time. So we are starting slowly and then potentially growing. And yeah, getting the community to get these ideas done and do some outsourcing.
Yeah, thank you.
No worries. Is that the last one?
Yep. Any other questions?
Okay. Nope. That's
cool.
it.
Thank you, guys.
Yeah. Thanks, everyone.
These are wrong slides. Okay, hello everyone. So my name is Thomas, and today I will present TLS Notary to you. So TLS Notary, or the title is Make Web Data Provable. And yeah, before we have a look at what TLS Notary does, let's first have a look at the organizations behind. So TLS Notary is a project inside of Privacy and Scaling Explorations, and Privacy and Scaling Explorations, or PSE, is inside the Ethereum Foundation. And what PSE, so it's a sub-team, and what we do is basically like make cryptography like easily usable for developers, like open source it, and also some applied research. And yeah, TLS Notary is one project inside of PSE. Okay, so first we should probably like, make clear what TLS Notary tries to solve. So what's TLS Notary? So it solves the problem of the portability of web data. So think about, for example, you're Alice now and you're going to visit some website. So then you're probably using the HTTPS protocol and you get some data. So now what you currently cannot do is like forward this data to some other party, in this example Bob, in some sort of cryptographically verifiable way. Right? Think about, you could do some screenshot and so on, but yeah, so there's not really a reason why Bob should trust you, right? On the other hand, there are quite a lot of use cases why this might be interesting or why you might want to do that. So for example, think about your government has some data about you and maybe you want to use that to go to some KYC provider and use it there. Or same with banks. Banks have like some information about you, maybe about your I don't know, credibility score or something like this, and you want to get a loan from some other creditor, so you would like to use this score there. There are many, many use cases. Also think about like just proving you own some social account, Reddit, Twitter, or even maybe you want to prove that you like, so you want to like help the Internet Archive scraping for some data, and you would like to attach a proof that this is really the website that you found, right? Or even in Web3, you maybe you want to trigger some smart contract function, but dependent on some valid input from Web2, right? So, yeah, it would be nice if this is possible. So let's first have a look at the internet today, right? So nowadays you have basically the TCP IP stack, which ensures that you are like connected to some computer that administers the connection and meters the data flow. And on top of that, you have this TLS, Transport Layer Security Protocol, and that's, so to say, the cryptography layer of the web, and this ensures two things. So the first one is authenticity. That basically means that the data you are sent and the data you are sending out has not been tampered with in transit. The other thing is, confidentiality, that it's encrypted, what you send and receive. So when you go to some website, you're probably using HTTPS, which is just HTTP together with TLS. I think it's, like, I don't know, 95 or probably 99% of the servers support that nowadays. Right, so coming back to what I said in the beginning, you have this authenticity and confidentiality, but what you don't have is portability of data. There's a cryptographic term for that, which is called non-repudiation. So Bob has no reason to believe that the data Alice sent to him is really coming from the website or just made up by her. And the reason for that is that in TLS, the keys you use to encrypt the data, they are symmetric keys. That means if you have a look here, the yellow keys, Alice basically has the same key the website uses for sending out the data, like encrypting it and creating authentication tags. So what she could do is she could just come up with some data and then just encrypt and create the tag herself for this data and then send it to Bob. And there's no way for him to differentiate between those two scenarios. Okay, so how can we fix this? Welcome to the bright world of TLS Notary. So when you use TLS Notary, you get also authenticity and confidentiality. But what you get some sort of like many other things also on top. So if we have a look at the picture, we'll see here that Alice is still connected via TLS with the website, and there's something like going on between ZK proofs on the data. So for example, like think about it, like you just want to prove you're over 18 without disclosing anything else coming from a government server. So just simple example. Okay. And if you have used TLS notary in this kind of setup where Alice is the prover and Bob is the verifier, there is no trust assumption. Alice simply proves some assertions about the data. What's nice about it is also that it's invisible to the website. So if you look at the picture for the website, it just looks like an ordinary TLS connection. And this is quite nice. So we see that there's no way for the website to really differentiate between if TLS notary is now run in the back or not. And this also means that, yeah, so when you use TLS notary, there's no, like, you don't need to change TLS in any way. Right? You can use the current deployment of TLS, which is quite nice, because changing such a standard probably takes decades if you even succeed. All right, okay. So before we now have a look at how TLS Notary achieves this portability of web data, let's have a look at some other solutions. So basically, there are like 3 solutions to this problem, and the first one, which is also the most elegant solution or straightforward, is just signing the data at the source. So think of, you have some web server and you could now sign the data. You could either like change or adapt TLS to do that, but you could also do it on the application layer. I think there's an RFC for this in HTTP, which is called I think SXG, which is just basically like hash the response and then sign it. So this is in some sense like the right solution, but there are some problems with this because it requires the website to implement this. And yeah, there are some like business models which rely on that, that they have basically the sovereignty over the data. While, so this is it's a problem. So there is some disincentive to adopt that or to do that. So what you could also do is use OAuth protocol, and then we would just delegate the access. So if I go to some website, the website requires some data about me, then I can send it to some data provider and then authorize the data provider to forward data from myself to this website, right? But yeah, there are problems. So first now the data provider knows exactly what you're going to do with your data, and if he doesn't like it, maybe he wants to censor you or like doesn't allow it. Also, the website needs to implement it. Yeah. And the last thing you can do is the proxy approach. So if you have a look at this picture, what you could do is, well, you would move Bob, the verifier, in between Alice and the website, and then you would send the requests to Bob, and Bob forwards them to the website responds, and Bob sends back response to Alice. So the nice thing is that the website doesn't have to cooperate in this case, but you run into other problems here, because now Bob is basically the proxy and always uses the same IP, so it's easily to block at scale. And also, your protocol gets some other like security assumption which rely on the network topology. Like think about if Alice, for example, wants to prove something, but she is like an internet service provider who controls the network topology in some way, she can maybe sneak herself again in between the proxy and the website. So you run into problems with that. And also, even if it's only encrypted traffic you send through the proxy and then do a zero-knowledge proof afterwards, you still have that, like the proxy knows to which website or server the data are sent because it has to forward it. So this is like what you can do in maybe the solutions which directly come to your mind. Now we have a look at TLS Notary. So TLS Notary uses an entirely cryptographic approach to this problem, and that is multi-party computation. So multi-party computation is if you have two parties or like even several parties, and each of them has some sort of secret input, and they want to compute a function which is like the output of on these secret inputs. So like Alice has an input X, Bob input Y. This should remain private during and after the computation. And yeah, like you compute a function on that, and this should be public, or maybe only returned to one of the parties or subset. That's also possible. Yeah, and this is exactly what TLS Notary does. So yeah, Alice is connected via TLS with the website, and in the back she runs this MPC TLS connection together with Bob. Yeah, you can think about like that they, in some sense, do what is necessary for TLS together as the client now split between two parties, and they compute everything together, like the key exchange, the request encryption, response decryption, all that kind of stuff is now done in MPC. That's basically the idea how it works. All right. So this was like the general introduction from like the bird's eye view to the problem. And now I want to go a little bit more into the detail. So like for the remaining part of this talk, we have like basically 2 chapters. The first one is like a little bit about the techniques and cryptography involved. And yeah, then we'll have a look at the phases of the protocol. So for the techniques, we have oblivious transfer, which is some like of general, yeah, like some construction which is used or which is necessary for all other protocols we are using. So specifically garbled circuits for like, yeah, general MPC computations. For binary stuff, then we have this OLI or VOLI, we'll come to that in a minute, for computing, yeah, doing computations which with larger prime fields. And then also we have to run some interactive zero-knowledge protocol in the end. We'll have a short look at what that does. Yeah. And for TLS Notary, yeah, we start with some pre-processing phase. That's basically doing computation before the connection is online. And then you have the, so to say, the TLS phases, like you have the key exchange, then you have the pseudo-random function to stretch the pre-master secret to the master secret. And then you have the actual traffic phase, like encryption of requests, sending out and getting server responses, decrypting them. And in the end, we'll have to do some proving. Okay, so I suggest let's first start with the techniques and have a look at oblivious transfer. So what is oblivious transfer? High level, what's the idea of the functionality? Like you have a sender and a receiver. The sender has 2 messages, M0 and M1, and the receiver has a selection bit C, which is either 0 or 1. And now basically PS sends M0 and M1 in a way, I say in a way because that's important to PR, so that PR only learns the message which belongs to his selection bit. So if C is 1, M, he will only get M1 and vice versa. And yeah, PS will learn nothing, especially not the selection bit. And if you think about it, you need cryptography to implement that. You especially you need public key cryptography for that. And there are different variants of that. So this is what I just showed here to you is 1 out of 2 oblivious transfer. There is random OT, where the messages and the selection bits cannot be like chosen by the parties. There's correlated OT, where these messages have some sort of correlation. And this we will see in a minute where we'll need this. But think about this as a basic building block inside of TLS Notary, which is basically used nearly everywhere. Okay, so now we have had a look at OT, so now we need to talk about garbled circuits. So garbled circuits is a general purpose MPC protocol, so that means you can compute any function with it, and especially you want to use it if you are like in a binary context. Think about like a binary, just 0 and 1, because then it's pretty efficient. So especially we don't use that for large prime fields, because then it becomes very inefficient. So in its general purpose, you can compute any function with it. And what's especially nice about garbled circuits is that, so usually when you do MPC, I mean, there are other ways to do MPC. The problem is that most or many protocols are not very efficient because you have many like messages sent around. And the number of messages you have to send around depends on the function or on the circuit depth, so to say. And this is not true for garbled circuits. And this is very nice, so it gives you some like nice performance, right? Because you send something in the beginning and you send something in the end, and that's it. Yeah. So, okay, how does this work? We have two parties, the garbler and the evaluator. So each of them have some sort of secret input, xg and ye, and again, compute some function on that. So, okay, I think to get this from a high-level perspective, we need to think about as the function as basically as like a circuit. Think about XOR or AND gates, right? And then you have like many gates in a circuit. Like think about your circuit as an array of gates, and every gate, think of it as a truth table. So for example, an AND gate, yeah, you have like, this truth table would basically for an AND gate consist of 0, 0, 0, 1, right? And you have 4 rows, and depending on, the row is basically determined by like if the input is 0, 0, then you get a 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. That's basically, you get the idea. So from there, we go now to a gate with wire labels, and you can think about these wire labels just as some sort of random strings, right? So we will see that the garbler will garble, we say he garbles the circuit. That means like he will do something with this circuit, and what he will do is like he will come up with these wire labels. And think about now not 0 and 1 flowing through the circuit, but these random wire labels, and only the garbler now knows which wire label belongs to either 0 or which wire label belongs to 1. This especially means that an AND gate here and an AND gate there in the circuit don't have the same truth table. Yeah? So right now the evaluator already doesn't know which values flow through the circuit, but now we have to do one more thing. We have to like encrypt it, so that basically the evaluator can only like evaluate the circuit on the correct path, which is like dictated by the choice of inputs, right? So for example, this especially means for an AND gate, let's just focus on the first row. You would like encrypt the wire label belonging to the clear value 0 with a wire label flowing in I and j belonging both to the clear values of 0. And you do that for all the 4 rows basically, and then you have, so to say, a garbled gate, right? And then think about the circuit as like a huge array of these garbled gates. And basically that's it. So now what does the garbler do? Now the garbler, he garbled the circuits, he sends over all these like encrypted or garbled gates to the evaluator. Then he sends over his active input labels, the WI, because remember, like only he knows if they belong to either 0 or 1. The evaluator, for him, it's just like random. And now the question is, how does the evaluator get his own input labels? Because remember, we have a function. The garbler has some input to the function, but also the evaluator, right? And here you need then oblivious transfer for this, so that the evaluator basically gets his input wire labels without the garbler learning the clear values behind it. And that's it. Then the evaluator will start basically with the first input layer of the circuit and like work himself through the circuit, doing decrypting gate by gate on the right path through it, and in the end he will arrive at the active output wire labels, right? Still the 128-bit like random numbers. So what do we do now? Now we come basically to the output decoding phase, and what happens here is now it depends on who should learn the output of this function. So what you can do is you can send the decoding information, which is the mapping from wire labels to clear values, can send that to the evaluator, then the evaluator will learn the output, or you can basically have the evaluator send his active output labels back to the garbler, and then the garbler will learn it, and if you do both parties learn it. And this is like the gist of or behind garbled circuits, how it works. So what I should say is let's say, for example, you want to gobble an AES circuit, so you have to do all of this per one evaluation, right? So if you want like compute an AES again on some different input, you have to gobble all of that again. So this is not FHE, right? It's different. Okay. So, and because you have to do all of this again and again, like think of, we have many, many circuits in TLS Notary with many, many more gates. So we want to have this as efficient as possible. And there are some optimizations you can use for it. I don't go into the details here, but think about like going from, if you think about one gate with this truth table, like 4 rows, you can get down to 2 rows. Yeah, so there are these techniques which are called row reduction and half gates. You get to 2 rows with 3 XOR. You basically even don't have to send XOR gates to the evaluator. You can just so to say incorporate them. And there's even something you can do to improve the performance of your gobbling by using a fixed key AES cipher. So again, this is used whenever we want to compute something like something in a binary field. This means especially AES and SHA. Okay, that's it for gobbled circuits. So now we have a problem because, I mean, we've done now, like, we have a tool for general purpose MPC for binary fields. But if you think about TLS, for example, the key exchange, there's also like, there are big prime fields involved because you deal with elliptic curves. So what do we do here? That's where oblivious linear evaluation or OLI comes into play. And you can think about it as a tool to like compute with these big numbers and prime fields efficiently in a way. So you have, again, 2 parties, PA and PB, and they have their inputs, A and B. These are like from elements of a big prime field. And what you get out is this X and Y. Sometimes X can also be the input, but yeah, let's not focus on that here. What you get is the output in such a way that it fulfills this equation, so that you have like Y is equal to A times B plus X. And if you rearrange that, you arrive at Y minus X is equal to A times B, or Y plus minus X is equal to A times B. And that's why this is also called like M to A. You should think about it like you can basically convert your multiplication into an addition, right? And if you now also have the vice versa as a building block, which is called A to M, like going from an addition to a multiplication, you have to think about, like, you have to some big equation, and by using either M to A and A to M iteratively on this equation, you can basically shrink it down to into some result. And that's exactly what we do. Whenever like we are forced to deal with big prime fields, we're using these two to do computation. Yeah, and they also play a big role in our interactive zero-knowledge protocol. So especially as a vectorized version of it, which is called VOLI. Yeah, that's basically like, think about just doing this several times, but the B is fixed. All right, and in a way, that's like the big building blocks we use in TLS Notary, like from the conceptual idea. So now we can have a look at TLS Notary, what it does, and yeah, like, okay, pre-processing. So what is pre-processing? So when you have like, we're doing multi-party computation, and that's like takes a lot of time to do the computation, right? But you have to remember, I mean, there is a server waiting for requests and responses. And many server implement some sort of cutoff. So if they don't get like an answer in like, I think a minute or whatever, they just shut down the connection. So what you want to do is like not run into that, and that's why you move all the parts of your computation, you can move into an offline phase before the online phase. Yeah, and that's what pre-processing is about. So first we ask the developer to specify the expected traffic amount. So we have these values, max send, max receive online. And that's basically, we ask you, tell us how many bytes you're expecting to send to the server and how many bytes are basically, are you expecting the server to respond. And based on that, we do like the pre-processing, because we need some sort of gauge of, like how much do we need to pre-process. And if we know that, we'll start our OT machinery. Like, remember from before, OT, very important, needed nearly everywhere. So there's a problem with OT. So like, OT can only be done with public key cryptography. And public key cryptography is, like, considering the time it takes or the performance, not that great. Now we need many OTs, like think of millions. So what you can do now is basically use some sort of base amount of real OTs and then do like a blow up, like an increase the number, like think of, you start with 100 real OTs, and then if you use an OT extension, you can get like thousands of OTs from these bootstrap OTs. Okay, and that's what we do here. So we use like CO15 as a protocol for our base OTs. It uses elliptic curves. And then we use an OT extension COS15, which is it's just like a random Oracle model protocol. It helps basically to like, it uses symmetric key cryptography to like get many OTs from that. And that's why it works, because the extension works without public key cryptography, so that's very efficient. And we use this OT extension then nearly everywhere in our protocol, except for our interactive zero-knowledge protocol, because that's even more OT hungry, and there we need like think of a much more powerful OT extension. And there we use the ferret protocol, which is based on learning parity, also the PRF circuit, and there's also a small garbled circuit involved in key exchange. And we also prepare our interactive zero-knowledge protocol. Okay, so now we are in the key exchange. How does this work? So the general idea here is, so in TLS you just have client server, and the easiest picture to think about this is to split now the client between prover and verifier, right? And this is also the exact reason how, in some sense, why TLS notary works, because you split the client key between prover and verifier. Now the prover hasn't the full key anymore, so that means especially that Alice cannot like encrypt or decrypt anything without Bob, right? So that means like she cannot make up some traffic and like claim it would come from the server. That's the general idea of why and how it works. Okay, let's quickly go through here. So the verifier comes up with some ephemeral public key, sends it to the prover. The prover adds his public key to it and sends it to the server. Now the server can like derive the elliptic curve, what's it called, this ECDH secret, the pre-master secret. Right, then he also sends his public key over to the prover forwards it. So, and now prover and verifier each on their own can basically come up with an ECDH share of the secret. Now these shares are just like shares under elliptic curve point addition, which is not ideal, because remember we want like you have these like PMS shares under EC point addition, but what we would like to do is like we need to feed that in the PRF to get the master secret and ultimately the session keys. But if you remember, the PRF is SHA, basically SHA circuits in some sophisticated way, which is binary. So we'll use garbled circuits, but these are like big numbers. So what we do here is we compute, that's in this MPC box, we compute sharing, we go from this elliptic curve point sharing of keys just to a binary XOR sharing. And then we can feed it in the PRF to compute the session keys. Right. Okay, so now basically, we have computed, like, we have done this key exchange, then we have fed all this as an input into the PRF. The PRF, of course, computed with garbled circuits, like into PC. And now we arrived with the session secrets, right? So, and we can use them like now in the online traffic phase for the encryption and decryption. So how does it work? So the prover has CWK as client write key, and of course he knows the plain text he wants to send to the server. The verifier has his client write key share, and now they use it as an input for AES CTR. So maybe one thing. So the encryption and decryption in TLS is mostly AES GCM, so that's the most common cipher suite. I've put into this box AES CTR because AES GCM is like just normal AES CTR with some sort of authentication mechanism, which is Ghash. And I don't want to go into the details of Ghash in this slide, so let's just focus on like what happens to the actual actual requests and responses. Yeah. So AES CTR is then here like executed between prover and verifier. Again, AES binary circuit. So we use garbled circuits to compute that between prover and verifier, and out pops the ciphertext. Ciphertext, both parties get it. Prover sends the ciphertext to the server, and verifier also gets the ciphertext. So for response decryption, it's kind of similar. So now you use the server write key share from the prover and verifier server write key share as an input. So the prover got the ciphertext from the server, then forwards it to the verifier, and they both supply it as a public input to the AES CTR circuit. Again, like garbled circuits, they decrypt it and they get a plain text, but no, sorry, not they, only the prover gets the plain text, because yeah, we want to hide it from the verifier because he shouldn't know the plain text. All right. There is an optimization you can do here, which is called deferred decryption. And that's basically if you only have like one request, one response, there is no reason to like decrypt the response in the online phase, because you can do it afterwards, and then you don't incur any MPC overhead on that, right? So why can you do that? And that's because after closing the TLS connection, that's pretty nice, the verifier has no secrets anymore. So think about these SWK and CWK. So after the connection is done, there's no reason to keep them secret anymore because the connection is closed. And that is quite nice because now we can use that and prove the correctness of our computations. So think about now, let me think about it. Okay. So first, so we prove now the correctness of the computation because the verifier has no secrets anymore. For that, we use an efficient interactive zero-knowledge protocol that is Quicksilver. And you have to think about it like from a high-level perspective, like we are gonna redo all the computations or all the garbled circuit computations from the online phase. But we do that like not in MPC, it's like you create these MACs, these MI, and you create the keys, KI, and you have to think about it like you create the MACs for the prover and the keys for the verifier, and they always fulfill this equation. And then the prover and the verifier works through the circuits of the online phase, and in a way, this is a check for the verifier to check if the prover like cheated or not. Because if everything is correct, then in the end, this equation will also hold on the circuit outputs. And that's the idea of how it works. I mean, this was a little bit simplified, but it's a general high-level idea. Right. So, and you do that for all garbled circuits computation in the online phase. And we also prove the knowledge of the clear text for the server responses for the prover. All right. So there's one thing you can do. You can you can decode the server write key for the verifier, which means like that's the key the server uses basically to encrypt the messages, and you can decode it already in the online phase if and only if you have no secrets, or if you don't expect any secrets in the server response. And this gives you like it's more like efficient and gives you like a better and more easy commitment. But you can only do that if there are no secrets expected. All right, so that was basically the gist about how TLS notary works. I mean, there are of course some more details, but that's the high-level idea. So where are we currently? So everything works quite nicely, I would say. We are in the moment like doing some performance improvements and adding additional features. So in the last few months, like, I don't know, the PRF was improved, and also like the number of round trips. So we are in this phase where developers reach out and ask us to implement some features. For example, in the last weeks, we added different commitment types. We also added support for mutual TLS, which is basically client authentication. And also in our notary server, we added JWT authentication. So think about like, we're in this phase where we're stabilizing, improving performance, and adding some features. And the next big point on the horizon for us is adding a plugin system to give developers some sort of fine-grained control of how exactly they want to run the prover, or how exactly in which environment and with which settings the verifier or notary should be run. So it will be some sort of plugin system. And also an on-chain verifier is still interesting. So think about that's this case where you want to use Web 2 data to trigger something in a smart contract. Of course, the smart contract cannot participate in this MPC TLS connection. So you get a trust assumption there in the form of a notary. Yeah? And then it's still not like, it requires some more research of how to do that, because if you then have a verifier in a smart contract, it's still the question of how you like check the correctness of the certificate chain. So it's like ongoing research to some degree. And also we want to add support for TLS 1.3. Currently only 1.2 is supported. And I'm sure there are probably some other things which will pop up in the coming months. Yeah, thanks. So this is our team. I've put some links here, like our website and our documentation, which we definitely need to improve. And also links to some GitHub repositories, the core protocol, JavaScript bindings, and also our browser extension. Yeah, thanks. You do you? Say? I don't know.
6:36.
Yeah. So.
Questions?
Yeah.
Okay, thank you. So just to be sure, I'm not into cryptography very much, but the verifier doesn't need to be online. He will provide his stuff, and it will be later used.
So I mean, it depends on how you operate it. So if you like, so basically, you can have a direct verifier, like I showed in all these pictures. Then it needs to be online because it participates in this MPC TLS phase, which is exactly at the same time where the connection is open to the server. What you can also do is like, you can sort of outsource that to some notary. And that's basically a server which does like, where you create commitments for this session or for the TLS session in some form. And this is signed by the notary and then returned to you. And then you can you can later use that then for some verifier. So these are basically the two modes you can do. But for this MPC TLS stuff, you need to be online. Yeah. Yeah, there are some like some startups, I would say, which use TLS notary to, I mean, yeah, for various use cases. Yeah.
Thomas, when you explained the proxy approach,
Mm-hmm.
I think you didn't want to say it, but that's what Reclaim does, right?
Yeah. Mm-hmm. We are also thinking about implementing this as a mode of operation.
Okay.
Yeah, because I mean, it's like it's just like it depends on what you. I mean, if you want to have like the best of security, you should probably do MPC. But if you maybe like, yeah, you're more interested in like performance, and honestly, there's not so much to lose in what we do, depending on the use case where you use it. It can be a viable alternative to use a proxy approach.
But isn't it, so if the MPC is between the client and the notary?
Yeah, well, yeah, the client is now the prover. Oh, sorry, can you say again?
The MPC computation is both done by the notary
Yeah.
and the
Prover. Yeah.
So if I understand correctly, the prover is I'm the user that's trying to prove that data.
Yeah.
And the other one is the TLS notary, right?
Yeah.
Okay, so I have to trust that your notary is
Right. So
honest, right?
right. So if you, that's exactly the thing. So if you have a notary, then who basically helps you to create a commitment and then signs it, so that you get an attestation, which is later presentable at to some verifier. In this case, you have a trust assumption here. Yeah. But if you have like only a verifier, like there is like you directly prove something about the ciphertext, or like in this case, there's no trust assumption because the verifier, I mean, it has to trust himself. So, yeah.
Right. Okay. Yeah. No, I'm just coming from the point of view that in MPC, it's cool to have more players doing the computation than just two, like just in general.
Are you talking about like maybe having more like notaries in this? Yeah. So that was some topic quite some months ago. So the thing is, you can do garbled circuits with multiple parties, like not only two, you can, but it's like some sort of little bit esoteric. I mean, it's like, there are like papers about that, it works in theory, but it gets complicated, and also you always have to keep an eye on the performance. So it's right, like, yeah.
Yeah, okay.
Yeah.
It would be cool to try to forge a proof if one of the MPC parties is not honest. To see actually like how hard it is or how feasible it is.
Yeah. I mean,
compromise a notary to be like, actually you thought that.
we played a little bit with it, but this would be some sort of like an effort in its own, and there are like more important things currently, like yeah.
Well, yeah, I'm a bit.
No, but it's definitely interesting, yeah.
Or also the other way, which is the origin server.
Sorry?
Or also another attack vector would be that the app server that's sending the data.
Yeah.
It would forge its own TLS certificates to try to trick you into proving the wrong data.
Yeah, but I mean, then you need to fake the DNS. Yeah.
Something that like NSA could do.
Maybe.
Yeah. And the computation, where does it actually happen? In the prover or verifier or etc.?
Yeah, so I mean, the heavy computation part is on the parties who are involved in this MPC TLS connection, and that would be prover and verifier, yeah, or prover and notary, and then if you later present the proof to some verifier, this way verifier has not to do the MPC TLS part, but yeah, still there's some computation and verification to do, which makes it hard to run in a smart contract. So, but the majority of computation is this MPC TLS stuff. Yeah, I guess that's it. Thanks.